Redis is a great tool to speed up your application, so let's look at how and when to implement this in your Node projects and what Redis is all about. We're going to be doing this in a project-based approach, building out a backend using Express and TypeScript, so by the end of the video you have everything you need to implement this in your own projects. Before we jump into our project though, if you like tutorials like these and you want to see more, go ahead and subscribe. And if you like hearing about building and scaling software, subscribe to the Hacking Scale newsletter. I'll leave a link to that in the description down below. But now let's take a look at using Redis in Node. So let's start off with the main question then, and that is the why and what of Redis. Well, Redis is an in-memory data store, and this makes it really performant, which means it's the perfect tool to use as a cache to speed up our applications. But although Redis did begin as a caching database, I do want to point out it can now even be used as a primary one. To quickly explain how you may use it as a cache though, let's explore a caching pattern here called cache aside. In this pattern, when our application requests some data, let's say for a GET request, it's going to first check if it can get that data from our Redis store, and if so, it's going to simply return that, and that's called a cache hit. Otherwise, if it's missing, it's going to go ahead and get the data from our primary data store, so that could be a database or it could be a third-party API, for example, and then it's going to go ahead and that will be a cache miss. But then in your application, you can go ahead and then write that data to the cache so that next time you have that data ready to go in your Redis data. Now we can even set an expiry time on the data as well, so it will essentially be deleted from the Redis cache after a configurable amount of time, so you can have control over how new your cache data is. This has a few benefits. The first one is going to be that, as I said at the start, Redis is really performant, which can help reduce your latency, and this has even more of an impact if you're using a third-party API, for example, that might take a long time. Another benefit of caching is just that it's going to reduce the load on your database or your usage of a third-party API. Now this pattern here was for reading data, but what if we want to write some data? Well, we can utilize a pattern called write through. With this approach, we write to our main database and Redis at the same time. This just means that our data is ready to go in our Redis cache the moment it is created. Now, there are several caching pattern techniques that you can use, but the one you're going to use is going to depend a lot on your application type and a load of other variables like the data type as well. In this tutorial, I'm going to be showing you a simple cache aside implementation using a weather API, and for the other endpoints, I'll be covering how we can add and read the data from Redis, treating it like a primary database, but you can decide how to read or write it to your primary data store as well, and I'll point that out along the way. So let's quickly go over what we are building today. We're going to be making the simple backend for a restaurant directory here with the ability to review them, rank them, search for them, and get the weather for a restaurant as well. So we're going to have all of these endpoints here, and as you can see, there's a few post request ones, and we've got a few get request ones as well, and we've even got a delete one down here. To do this, what we're going to be doing is we're going to be setting up our backend in a Node application utilizing Express. We're going to add in Zod and TypeScript as well, and for the package, I'm going to be using Node Redis. Now, I'm using Node Redis instead of IO Redis, which is another popular Redis library, because it's the one the Redis team recommends now, and since they've taken ownership of IO Redis as well, it appears Node Redis is going to be the one that's getting the updates. So for our Redis features, I will be covering using pretty much all of the core Redis types here, with hashes, lists, sets, sorted sets, and strings, and then some of the more advanced features as well of modern Redis, including RedisJSON, Redis Search, and Bloom filters. Don't worry if you're not familiar with these though, I'll do my best to explain them as we go. So with our project overview and learning goals, let's go ahead and get started. Now, when we get coding, I'm going to be making sure that my git commits line up with the chapters so you can see exactly what changed in each step, and I'll leave a link to that repo that we're going to be building today in the description down below. Now, before we do any coding, we're going to need a Redis server. You may already have one set up, but if you don't, you can pretty much install Redis anywhere, and I'll be using Docker for mine. I'll leave a link to this page in the description down below if you need to install it yourself. Another thing I do want to point out though is I will be using Redis Stack. Now, this has been created by the Redis team, and it adds a few more features on top of Redis, such as RedisJSON and Redis Search. If you just want to use the core Redis, don't worry, the rest of the features will work with that. Another benefit of the Redis stack though is it's going to set up Redis Insights for us. This is a visualization UI for our Redis data, and I'll be using that later just to help show you the structure of our data. So let's go ahead and find our Docker command here. So as you can see here, we've got how we can install it on Linux, Mac OS. I'm going to do the run Redis stack on Docker here, and what you can see is there's going to be two images. The Redis stack server is the one you're going to want to use in a production deployment, and we're going to be using this Redis stack one here, and we can go ahead and literally just copy this command down here to get started. Now this page also has some other useful commands as well, such as setting up persistence in Docker. But let's head over to a terminal now and set up our Redis stack. All we need to do then is paste in that command that we just copied. And now what I do want to just point out quickly is 6379 is going to be our Redis server port, and then 8001 here is going to be for the Redis Insights UI. So that's how we would connect that on localhost 8001. So once that command is complete, we can go ahead and verify that it's running. If we just simply do docker ps like so, we should see that our container is running with that Redis stack image there. Now let's go ahead and set up our project. To do this, I'm going to be creating a folder here called bytes. So that's going to be my project name. And then let's just go into that folder there. Now, once we're in here, what we're going to do is pnpm and then init, or you can do npm init if you're using that package manager. Now that that's done, we can go ahead and install a few of our dependencies now. So what we're first going to install is I'm going to do pnpm and then install. We're going to be installing Express. We're going to be installing NanoID there, Redis, and then also Zod like so. With those installed, we're going to go ahead and install some dev dependencies as well. So as we can see there, that is going to be @types/express, and then we're going to have the node types as well. So that's @types/node. Then we're also going to use TSX, and that's just going to be to run our TypeScript in development. And then we also need to install TypeScript, so we can go ahead and use that in our project. So once that's done, we can go ahead and open this up in VS Code. So for that, I'm going to do code. So with our project open in VS Code then, since we're using TypeScript, we need a tsconfig.json. So I'm going to add one here. And then inside of the tsconfig.json, I'm going to paste in the values that I like to use here. Now, I highly recommend checking out this article here, which is the tsconfig cheat sheet on Total TypeScript. Essentially, it's just going to go over the configuration options that you actually need to care about. And it will give you a brief guide on sort of how you can get set up for the perfect tsconfig for your application. So now let's head back to VS Code here. There's a few other things we want to set up. In package.json here, I want to set the type of this project here to a module like so. So all we need to do is just add type module as one of the keys here and then the value of module. And I also want to configure some of my scripts here. So let's change this test script here. What we'll do is we'll do dev. As I mentioned earlier, we installed TSX. This just allows us to run TypeScript directly from TSX without having to build and transpile our files to JavaScript first. So for this, what we can say is we can say TSX. Then we'll do watch here, and this is just going to run it in watch mode so that our application is just going to rebuild each time we make a change or save a file. And then we're also going to add in --env -file like so, and then we'll have .env, and we're going to set up an env file later, and this just means that it's loading in the values for us. And then finally, we can just run index.ts, which is a file that we'll be creating in a minute. Next, what we can add is we can just add in the build script, which is just simply going to be TSC. So that's going to build our files to JavaScript. And then finally, we could also add a start file or start script if you wanted to as well. And then this one here would simply just be node, and then it would be dist, and then it would be /index.js, since this will be running the actual transpiled code. So now that we've got that, we're going to go ahead and create our env file as well. So let's go ahead and create a .env. And then in this .env, what I'm going to add for initially is just going to be port, and we'll set this one here to 3000. Now, the last thing I'm going to do in this step is I'm just going to add in a gitignore, since I'm going to be making this a Git repo. So let's do .gitignore here. And for the gitignore, I like to use the GitHub repo here, which has a load of examples for different projects on what a gitignore may look like. I'm going to go ahead and copy the file here and paste it into our code there. Now, another thing I may want to do is actually, if I just change this script here for Node, let's go ahead and load in the env file here as well. So let's do env file and .env like we did up there, and make sure I've actually saved this file. So finally, I can go ahead and initialize my repository here, and I'll go ahead and save that as step 1, and that's going to be our project setup like so, and go ahead and commit that so you can follow along. Next, let's go ahead and set up Express to handle all of our endpoints. To do that, we need to create an entry point. So we're going to create a new file at the root level here. That's going to be called index.ts. At the top of this file, we're going to go ahead and import Express, and that's going to be from Express like so. Then we're also going to set up the port from the environment variable. So we'll do const port here. This is going to equal to process.env and then the port as we had. But then we'll also set this to have a default of 3000 as well. Underneath here, we can go ahead and set up the application. That's going to be const app. That's going to equal Express here, and then we'll run that function like so. Now we're also going to add in the Express.json middleware, so we can go ahead and use JSON with our Express app. So for that, you can do app.use here, and then we'll do Express, and then that's going to be .json like so, and then we can use that as a function as well. Then we need to go ahead and make sure that our application is actually listening on our port. So for that, we can go app and then .listen. And then inside of this listen function here, we provide it with the port. We also then have a function for what happens if everything is running successfully. So if it is listening, so inside of here, we can do something like console.log, and we'll just add it in a template literal. And I'm just going to say, let's say application running on port. And then we'll use the port number inside of here like so. So we can just say port, and that's going to print out application running on port 3000, hopefully, if everything has gone correct. Otherwise, what we can do is we can handle the error event as well. So for this, we can do .on, and then we can pass it an event. So we're going to use the error event. And then inside of this function here, we can get the actual error out, and then we can handle this in here as well. So for that, I'm simply just going to throw a new error. So I'll do throw new error, and then we'll throw an error with the error.message like so. And that's just going to gracefully handle any errors that we may get in our application that we aren't expecting. Now what I need to do is go ahead and actually set up the routing for our application, so how we can get to our various endpoints. Now for this, I'm actually going to be using modular routing in Express. This just allows me to organize my routes into separate files or modules, each of them handling a specific endpoint or specific part, and it just really helps with organization. To do that, I'm going to go ahead and create a new folder, and inside of this folder, what we're going to do is we're going to call this one routes. Inside of here, we're going to define two new files. One of them is going to be called cuisines.ts, and the other one is going to be called restaurants.ts, like so. Then inside of one of these, so the restaurants.ts, for example, we can go ahead and do import Express again, and that's going to be from Express, like so. And then what we do under here is we say const router, and that's going to equal to express.router, like so. And then we can go ahead and do export default and then router like so. And we're going to go ahead and copy this code over to our cuisines.ts as well. So let's go ahead and save that, copy it over to cuisines.ts, and then save that here. Next, in our index.ts, we need to go ahead and tell Express to use these routers. And essentially, this is where we're going to point all of /cuisines slug essentially to this file here, and then anything under /restaurants to this. Now, the file name doesn't actually matter, but obviously it's useful to name them the same way you would name sort of your URLs. So to get started using these, we need to import that default export. So we go to the top of the file here. We'll do import, and then let's import the restaurants router like so. That's going to be from the file we just created. So that's going to be .routes, and then it's going to be /restaurants.js like so. And then we'll also do the same for the cuisines router. So it's going to be cuisines router, and that's going to be from ./routes/cuisines. Now we can tell Express to use these and what path to use them at. For that, we can just simply say app.use. We provide the path, so let's provide the restaurants one first. So that's going to be /restaurants, and then we'll pass that the restaurants router, and we'll do the same for cuisines again down here. So that's going to be /cuisines like so, and then we'll pass that the cuisines router like this. So we can go ahead and save that. Now, essentially what this is going to be doing, if I go to my restaurants.ts, and if I define an endpoint in here now, for that we can say router, and then we can do a get request, for example. If I then provided the path as a /, this is actually going to be handled by /restaurants. So if I went to localhost 3000 /restaurants, it's going to be hitting this endpoint here, as that's what we've defined with essentially this path here, is we're saying anything under this path, handle with this router here. So back in our restaurants router then, let's go ahead and test that this is actually working. So for that, we can just simply say async, and then we'll do request and response. And then inside of this function here, we can go ahead and return res.send, and then we'll do something simple like hello world for now. And we can go ahead and start our application. So let's load up a terminal. And inside of that terminal, we can go ahead and run that dev command that we created earlier. So pm run dev. And what we should see is we get our application is running on port 3000 like we configured it from our env file. And that's the console message that we set up. And now if I go ahead and send a get request to localhost 3000 /restaurants, I should receive hello world. So I'm going to be using Insomnia here, which is pretty similar to Postman to send my requests for testing. Let's go ahead and create a new HTTP request. It's going to be a GET request. It's going to be to localhost 3000 here. And then, as I said, it's not going to be at the path /, it's going to be at the path /restaurants like so. We go ahead and hit send here. We should see that we're getting back hello world. So we know now that our routers are working. The next thing I'm going to do for our Express setup though is I'm going to create some utility functions, as I like to standardize my API responses. This just makes it easier to maintain a uniform API structure by creating some helper functions. To do that, what we'll do is we'll create a new folder here, and we'll call this utils. And then inside of this folder, what I'm going to do is create one called responses.ts. Now inside of here, we're just going to import one type, and that's going to be import type, and that's going to be response here, and that's going to come from Express again. And then what we'll do is we'll define what's going to happen when we have a success response. So for this, we can say export function, and then we'll do success response like so. And then inside of this function, we're going to take in a few arguments. One of them is going to be the response, and then we'll use that type that we just created. One is going to be the data, and we're going to set this to any with TypeScript. And then we'll also have a message here as well, which is going to be a string. And we're also going to have a default on this of success like so. Then inside of this function, all we have to do is we can simply say return, and then we'll return the response. We'll return a status code. And since this is going to be my success response, I'm going to return a status code of 200. And this is the reason that we actually create these helpers, is now what I'm going to do is I'm going to do .json. And then for all of my endpoints, I want to return a standardized format. And that format is simply going to be a JSON object that has a success. So for this success response, obviously that's going to be true. It's going to have a message, and then it's also going to have any data that we want to send back with that API endpoint. So we can go ahead and save that, and let's go ahead and create our one for the error as well. So we'll do the same thing with export function, and then this is going to be error response. And then inside of here, what we'll do is we'll take in that response again with type response. What we're also going to take in is a status code. So it's going to be the HTTP status. So let's say we'd want a 404 or a 400 or a 500 internal server error, for example. So this one here is going to be a number. And then finally, we'll also take in the error. And again, you could leave this as something like any, but we'll take in the error as a string here. And then inside of here, all we have to do is return. And then we'll do response.status. We'll use the status code that we got from the arguments. Then I'll go ahead and return some JSON. Again, as I said, we're doing this in a nice standardized way. This is going to be success of false, of course. And then finally, we can return the error that we sent through using this error response. And you'll see a bit later how we utilize these and how it can really help just to make sure that we have this standardized format. And as I said, this really helps if you're linking this up to a front end, for example. You always know essentially that your data is coming back looking like this. Let's go ahead and just minimize this terminal here, as the next thing I want to create is an error handler middleware for Express. So at the moment with Express, if we go to our index.ts, you see that we have this throw new error down here, but essentially nothing's going to be returned back to the endpoint if there's been an unexpected error. So to handle that, what we'll do is we'll create a middleware. So let's create a new folder here, and we'll call this middlewares, as we'll be adding a few more later. Then we're also going to create a file in here called errorhandler.ts. Inside of here, we're going to go ahead and import a few types. So let's do import type here. We're going to import request. We're going to import response. And then finally, next function here. And that's all going to be coming from Express like so. Now we can go ahead and just set up our error handler. That's going to be a function. So it's going to be export and then function here. And that's going to be called error handler. And we're going to take in a few arguments here. And as I said, we're creating an Express middleware. So we need to define an error. That's going to have a type of any. This is going to have a request as well, and that's going to have the type of request that we imported. We'll have a response. Again, that's going to be response. And then finally, we'll also have next here, and that's going to be next function like so. And then inside of here, we can simply say console.error or handle the error however you like. And then for this, we'll just print out the error. Next, we can go ahead and actually return a status code of 500. And to do that, we'll use that new error response helper that we built out earlier. So we can say error response here, and we'll make sure we're importing that from utils/responses. And then inside of here, we pass it the response. We give it a status code. Now, since this is going to be handling unexpected errors, we'll give this 500. And then finally, we can just pass through the error like so. So what this middleware is going to be doing in Express is essentially going to be saying, if we've gone through all of our routes and then an unexpected error has occurred, go ahead and send back a 500 to the client with an error. That just means that on sort of your front end, for example, you can see that something's gone wrong and that it's not just going to time out. We need to tell Express to use this middleware now. So let's go back to our index.ts. Now make sure you always put this error handler middleware last, so where we have our app.users. So we're going to do app.use here, and then finally we'll do error handler, and we'll make sure to be importing that from middlewares/error handler. So let's go ahead and save all of this. Now that is the setup for Express done there. So I'll go ahead and commit all of this as step 2, set up Express. Next, what we're going to be doing is setting up Zod. Now, if you haven't seen Zod before, it provides type-safe, declarative schema validation, and it's also going to work at runtime and be compatible with TypeScript. We're going to be using it for validating that the JSON we're getting through in our post request is in a format that we're expecting. So we go to our restaurant.ts here. Let's see an example of this. If I change this to router.post, and let's say we wanted to get some of the post request information off of the body as JSON, what we could do here is we could say const data equals request.body. But at the moment, we have no validation that this body is in that format that we're expecting. We could actually send through any data here, and you can see the data here shows that as it has a type of any. Now, obviously, you could write a bunch of code here to check for different things on that, and that's just going to be a lot of repetitive code. And this is where we can use something like Zod to make sure that we don't have to write all of that boilerplate code, and it's also going to handle reporting the errors for us as well. And as I said, it handles the TypeScript integration too. So what we need to do is define a couple of schemas. let's go ahead and create a new folder. Let's call this folder here schemas. And then we'll create a new file in here. One of them is just going to be called restaurant.ts, like so. And then in here, we're going to import one thing, and that's going to be import z, and that is going to be coming from Zod, like so. Next, we need to define the schemas. Now I'm going to define all of the schemas that I'm going to be using in this application. So one of them here is going to be export const, and then it's going to be restaurant schema. So this is going to be for the post request of creating a new restaurant. Now in Zod, all we have to do is we can say that we want this to be an object. And then on this object, we're going to want to have a key of name. And we can set this key of name to make sure that the value is a string. And we can also make sure that the string has a minimum length of 1. Next, I also want a location string. So we'll do z.string again, and we'll do the minimum length of 1. And then finally, I want a cuisines array. So we can say cuisines here, like so. I'm going to want this to be an array. So we can do z.array. And then inside of this array, I'm going to want all of the values of the array to be a string. And again, have a minimum length of 1. So you can see here how we've built out a schema, and then you can see how this is going to go ahead and validate this when we use this in the request body, and I'll show you that in a bit. Next, what I want to do is also create a restaurant details schema. So this is going to be a little more complex data structure, and it's going to have a bit more information about each individual restaurant, and this is also going to be for a post request. So what we need to do is we need to say export const restaurant details here. This is going to equal an object as well. On this object, we're going to have a links key. This links key is going to head and be an array. And then this array is actually going to be an array of objects here. And then on each of these objects, I'm going to have a name. That's going to be the z.string like we've done before. And then also have a minimum length of 1. And then we're also going to have the URL. And again, that's going to be a string. So we'll do z.string and then min1 here. Next, on this object, I'm also going to want some contact details. So we'll add in that contact key here. So that's going to be contact here. Then this is going to be an object. So we'll do z.object. And then on this object, I'm simply just going to want a phone number. We'll take this as a string like so with the minimum length of 1 like we've done before. And then we'll also do an email. Now with an email, you can do something cool here. If we make sure that this is a string first, we can then also check with Zod that it actually looks like an email like so. And I'll leave a link to the Zod documentation down below where you can find out all of the cool tricks you can do it for it and all of the different types of custom schemas that you could create. Now, finally, at the moment, if we hover over restaurant details here, what you'll notice is that it has a load of Z objects and the type isn't exactly mapping to how you'd think it would in TypeScript. I'm also going to want to change this name here quickly to just restaurant details schema. So if we want to just get the TypeScript types out from all of this validation, we can simply say export and then type, and then we'll do restaurant. And this is going to equal z.infer. And then we'll use our angled brackets here. And then this is going to be type of, and then restaurant details or restaurant schema for this one. And then we'll also have that for the restaurant details. So export type restaurant and then details. And this is going to again equal to z.infer with that type of inside of here. And then we'll use the restaurant details schema. We can see now if I hover over these restaurant details, you'll see that this maps now more to a traditional TypeScript type with essentially just what we have as the object. And this is an array of objects with name and URL there. And then we also have that contact information object. Let's go ahead and create a schema then for our reviews as well. So let's do new file. This is going to be called review.ts. Inside of this file, we'll do the same thing, which is import z from Zod, like so. And then we'll go ahead and create that schema. It's going to be export const review schema like so. This is going to be equal to an object. Now this one is going to be quite simple. I'm going to take in the review, which is essentially going to be the text body of our review. This again is just simply going to be a string with a minimum length of 1. Then we're also going to take in a rating, which is going to be a number between 1 and 5. And that's really cool with Zod as well. We can just handle validating that for us. So what we can say is z.number. And then we'll make sure this has a minimum of 1 and then also a maximum of 5. So we can do .max here and then we can say 5. And that's going to make sure when we do go ahead and validate our schema that the number, even if it is a number, is between 1 and 5. And then finally, we'll do that export type that we did before. So it's going to be export type of review and it's going to equal to the z.infer and then the angle brackets and then type of and then review schema like so. So now that we've done that, let's go ahead and see how we could use this. We're going to be using this in a middleware to make sure that we're just reducing sort of the boilerplate code that we're creating. And again, also making sure that we're returning our errors sort of in a nice standardized format. So to do that, if we go to middlewares here and we create a new file, we're going to create one called validate.ts. Inside of here, we're going to import a few things. Now we're going to import the types that we imported in our previous middleware. So it's going to be request, response, and then next function, like so. And that's going to be coming from Express. And then underneath here, we're also going to import Zod schema from Zod. So that's going to be import. And then this is going to be Zod schema, like so. And that's going to be coming from Zod. Now we need to go ahead and create our validate function middleware. For that, what we're going to do is we're going to be creating a function that then returns another function, which is going to be the Express middleware. This is just so we can actually provide it with some custom arguments like the schema. So to do that, we're going to do export const validate. Now this validate here is going to be a generic. So what we'll do in here is we'll do some angled brackets with a type of t here. And then we'll do brackets here. We're going to take in a schema. So this is the argument. And this schema is going to be of type Zod schema. And then again, our angle brackets, since we're going to be passing our generic through, as Zod schema is expecting a generic there. And then finally, as this is a function, we'll do our arrow notation here. And here we're simply going to go ahead and return another function. So this one here is going to be the request. It's going to take in that request type. It's going to take in the response and then the response type. And then it's also going to take in next here, which is going to be next function, like so. And then here we can use our arrow notation again, but then we're going to run some logic within this function. So inside of these brackets here, let's go ahead and say const result. This is where we're going to be using the schema. But as I said, we're essentially making a middleware, so this can work with all of our Zod schemas. So what we'll do is we'll say schema. Then we're going to be running this safe pass function. Now this is the really cool part of Zod. If we now pass it the request body like so this could be for any of our post endpoints, the request body there. And now if this is sounding a little bit confusing, this will be a lot clearer once we actually go ahead and use this in an endpoint. And I'll show you that. I'll do that in a minute. But first what we do is we say schema.safePass and then request body. And remember, request body there can be any. But now this result object is going to have a success key on it. And that success key could be true or false, depending on whether it's actually been able to validate this data here. And if it hasn't been able to validate that data, this result key is also going to have the errors on it. So we can go ahead and use these now. So we can say if, and then we can do not essentially result.success. So if there isn't a success, we're going to go ahead and we're going to return a response, and that's going to have a status code here of 400 as it's a bad request. And then we're going to do .json, and then we'll send this through using that format that we've seen before. So that's going to be success of false. But then what we'll do is we'll add in errors here, and we can go ahead and simply just use the Zod errors by doing result.error, and then we say .errors like so. And that's going to print out to sort of the API, all of the errors, and formatted in the nice Zod way. Now, after this, what we can go ahead and do is we can simply just say next, and this is going to go ahead and run the next function in the Express middleware chain. And you'll see what I mean when we use this for our endpoint. So let's go ahead and use this in our restaurants.ts now. And as here, you can see what we had was that data with the request body being any. We want to make sure that this is validated to look like that restaurant schema that we created. So to use our middleware now, what we can go ahead and do is put a comma here, and we're going to want to run this first. So this will be validate like so. And then we'll go ahead and import that from the file that we created it in. But then we can run this as a function, as if you remember this function then returns another function. Inside of this function, we want to pass it the schema that we want to validate against. So that's going to be validate restaurant schema here. So this bit of the code here is not going to run if it hasn't been able to validate our request body against the schema that we just provided here. And that is going to be with the help of middleware. What you will notice though is the middleware doesn't actually change this data type here, but now we can actually go ahead and just safely assert that this type is a restaurant, as we know that it has been validated before this point. And we can go ahead and save that. I'm going to go ahead and load up Insomnia, and we'll see what all of these errors look like. So inside of Insomnia, I'm going to go ahead and change my request to a post request and hit send. And what you'll see is we're going to get back successful. So that's because we haven't actually sent it any JSON data yet. And you'll see what the errors are here. So you can see we got an invalid type. It wanted a string, but it received undefined. And that was for the name key. And as you can see there, it also has a message saying it's required. And then we've got the error types as well for all of that, as we were missing all of the information. Let's go ahead and provide it with some valid data then. So make sure we're sending the JSON type. I'm going to go ahead and paste in this example here. But you can see we've got a name with better food. We've got the location with a string, which is what we were expecting. And then we have that cuisines array with strings that we're also expecting there. Let's go ahead and hit send here. And what you'll see is we're simply getting back hello world, as what this has gone ahead and done is it's just run the next function essentially. It's got past this point here, and now we're running what we're expecting here. And as I said, we now know that the data that's come through is in the format we have expected. Hopefully then this makes a little bit more sense now that you've seen sort of how it flows through, and you can see how this validate middleware here just helps reduce a load of boilerplate code. And now we're not actually going to do an app.use on this validate middleware, as essentially you can sort of just say when you want to use it for a specific endpoint by using this sort of express chaining that we've done here. Now I'm going to go ahead and commit all of this as our step 3, and that's going to be set up Zod and middleware. So step 3, Zod and middleware, like so. Now the time has come to go ahead and set up our connection with Redis. To do this, what we'll do is inside of utils, we're going to create a new file. This is going to be called client.ts, and this is how we're going to set up the Redis client in here, which is essentially what handles the Redis connection. Now at the top of this, we're going to import, I'm going to import create client, and then we're also going to be importing a type as well, and that's going to be Redis and then client and then type. And all of this is going to be coming from the package simply called Redis, like so. On this line here, what we're going to say is we're going to say let client. Now this client is going to have a type of Redis client type that we just imported, or null. And then we're also going to set this to equal to null by default, as obviously when we start our application, there isn't going to be a client connection. Now we need to start the function that actually initializes this connection. For that, what we'll do is we'll say export async and then function. And this is going to be called initialize and then Redis and then client, like so. It's not going to have any arguments. But inside of here, what we're essentially going to be doing is we're going to be using what's sort of a singleton pattern. So with our Redis client here, we only want to set this up once sort of for the lifetime of our application. So what we'll first say is we'll say if there isn't a client, so if this is the first time sort of the client has been initialized, what we'll do in here is we'll say the client is now equal to create client, like so. And that's what we imported earlier. Then we can also go ahead and just handle some errors here and some connections. So we'll just simply say client.on, and then we'll handle the event of an error. And then in the event of an error, obviously we're going to get that out as an argument in this function here. And then in here, we can handle that by simply, I'm just going to do console.error, and then I'll do error like so. We can also go ahead and set up an event for, let's say, logging something if it has been connected. That's only really going to be useful for sort of debugging things. Let's go ahead and do client.on. Then also do connect here. And then inside of here, I'll just simply log out that our client is connected. So console.log. Then I'll just say Redis connected like so. Now what we need to do is we need to actually await the client connection here. So we need to make sure it has connected. So we'll do await client.connect. So this is only if the client hasn't been set up before. So outside of this, if it has been set up before, we just want to return the client instance that has already been set up. Now, essentially why we're doing this is it just helps to reduce the overhead of having to establish a connection each time we need Redis data. We're just going to use one client for the lifetime of the application. And if something does go wrong, and let's say it does disconnect, every time we call initialize Redis client anyway, it's going to make sure and check that the client does exist, and then go ahead and create it if it doesn't. To see an example of this actually running and making sure that our Redis client can connect, let's just go to one of our restaurant endpoints that we created earlier. And then inside of here, what we can say is const and then client. And this is going to equal to await. Make sure this is an equal sign. This is going to equal to await and then initialize Redis client like so. And you go ahead and save this. If I go to Insomnia now, and then I quickly send the same request that we sent before, what we should see is back in my console.log, I have Redis connected. Now it's worth pointing out that this create client function here does take in some arguments. So if you need to change your Redis URL, go ahead and do it here. But by default, it's going to be connecting to localhost and then that's 6379, which is just the default Redis port. So as I'm on that, I'm just going to go ahead and leave that as the default. Obviously worth noting there if you're using something like Redis in the cloud. Next, I want to create some utility functions to help us out with Redis keys. Now, Redis keys are essentially the unique identifier for storing and retrieving your data in Redis. Think of it a bit like an address. If I go to utils here and then I create one called keys.ts, essentially what we would have in Redis, if we wanted to store some hash data, some string data, anything like that, you would have a key for how you can actually go and look that value up. So for our application, what we'll be doing is we'll be doing a format where we essentially have a prefix for all of it. A prefix is just going to be really helpful to help avoid conflicts if you're using Redis for more than one service, say if you're building out some microservices. But let's say we wanted to get the data for a restaurant, our key might look a little something like this, and then this random string here is going to be the restaurant ID. So to help us out with actually building these out and using these colons as sort of the different namespaces and groupings, we're going to be creating a helper function. This one is going to be called export function, and that's going to be get key name. Then inside of here, we're going to get all of the arguments by using the spread operator. So that's going to be args. We're going to make sure all of these arguments are a string though. So we'll do an array of string like so. And what we're simply going to return from here is a template literal. Inside of this template literal, we're adding the prefix. So this is going to be my project name, for example, but this could be anything, or you don't even need a prefix. And then what we'll do inside of this template bit here is we'll say args, and then we're just going to join all of the arguments that we pass through to the getKeyName function, and we'll join all of them with a colon like so as the separator. So essentially what this function is going to help us out with, if let's say I did getKeyName and I wanted to build one for my restaurant. So let's say we do restaurant like so, and then I'd pass it the ID. Maybe I've generated this somewhere else. This is going to help us really quickly build out what I just showed you earlier, which is that key of bytes and then restaurant, and then whatever the ID is there. And we'll do a load of other helper functions in here later. As you'll see, Redis keys are pretty important, and it's nice to define them in a single place to make sure that you don't fall foul to any spelling mistakes or anything like that. And if you wanted to change the key, you can just change it in one place. So there we go. That is pretty much all of the setup that we need for Redis. So let's go ahead and commit all of this, and I'll save this as step 4 and then Redis setup. So now that we've covered essentially all of the basic boilerplate setup for our application, we're ready to use our first Redis data type, and that is going to be hashes. So hashes are field value pairs, and they're going to be useful for representing basic objects or a counter or something like that, and they can't have any nested data. What this means is essentially this is a hash down here. You can think of it like a simple table or a really simple object, and this field here and the value essentially can only be a string or a number. You couldn't store something like an array or another object as the value here. And then we also have fields are added and removed as needed. What this means is essentially there is no schema for this hash down here. So say we have ID, name, and rating, and we saved it like that. We could go ahead and add in a load of different fields on here or delete them. It's not going to check against any sort of type or anything like that. So for our application, what we'll be doing is we'll be going to be storing some basic restaurant information in a hash. So we might have a key that looks like this, for example. So you'd have this sort of restaurant grouping, and then you'd also have the ID for that restaurant. And then, as I said, we're going to be storing the basic information of things like the name and then the average rating for it or the location, for example. And then for more complex data structures, we'll be storing that in RedisJSON later, where we might want that contact details for that schema that we set up earlier. Now, some of the basic commands that we can use for hashes are down here. So this is a little bit of a cheat sheet, and you can also go ahead and consult the Redis documentation as well, as there's going to be a load more commands that we can go ahead and run for hashes. Well, let's look at how we can implement this in Node now. So back in our code then, as I said earlier, everything in Redis comes back to a key. So we're actually going to build out a helper function here just to make the key with that restaurant ID there. So what we'll call this one is we'll call this restaurant and then key by ID like so. And we're going to go ahead and make this a function. So that will be ID here with string. And then this function is simply going to return the getKeyName function. But then inside of here, we'll define this grouping as restaurants like so. And then I'll pass through the ID like this. So as I said, this is just going to be a helper function just to make sure that we're always using the same sort of format and that we're not going to have any spelling mistakes if we had to constantly make sure that our key was restaurants and then the ID. Let's go ahead and save this in and see where we're going to be using this. So as I mentioned earlier, we're going to be storing some basic information about a restaurant in the hash. So let's go ahead and go to our restaurant.ts endpoint. And as you saw earlier with our post request, we've essentially already got the data through, and we know that this has been validated using this validated middleware that we created earlier. Now what I'm going to do is I'm going to go ahead and move this const client equals await initialize Redis client. We're going to move this into a try catch block because at the moment I'm using Express 4 and that doesn't actually handle our sort of async errors. Express 5 is going to go ahead and handle this for us, and it's going to send this to our error handler middleware we created earlier. But since we're on Express 4, what we can say is we can say try, and then with the catch here, we're going to catch an error like so. And then inside of this error, what we'll do is we're going to run a next function. So that'll be next, not next tick. It's going to be next and then error like so. And we're going to go ahead and get the next function from our parameters up here. So we're just going to add an additional one here called next. What this is essentially doing is it's going to send any unexpected errors for us onto the next sort of function in the middleware chain of Express. And that is going to go ahead and then send that to that error handler middleware we created earlier. So now in our code, we already have the Redis client. And as I said earlier, we already have our data being validated. So next thing we can go ahead and do is just create a new restaurant ID. And for this, I'm going to be using what is called Nano ID here. Nano ID here is just a unique ID generator. And the IDs are also URL safe as well. And it's just a really handy package that I like to use. The next thing we're going to do is we're going to define our restaurant key. Now, as you saw earlier when we created that keys helper function, what we need is the actual value for that key now using our new restaurant ID. So this is where we're going to be calling that restaurant key by ID function and making sure we import that from that keys file. And then in here, we can just pass it the new ID that we have created. Now, finally, we're going to want to have some hash data. As you may remember, our data here is coming through as a name, location, and cuisines with a string and an array of strings for cuisines there. And if you remember from our hashes explainer, hashes can't actually store arrays or objects. Essentially, they can only store strings or numbers. So what I'm going to do down here is I'm just going to take off the cuisines from our data. And then I'm also going to go ahead and add in the ID onto the hash as well. It's just useful to have it there if you want to request that data later. Even though the key does have the ID, I just like to store it in the hash as well. So for the hash data here, we're going to do ID here, and then we'll do name. The name here is just going to equal data.name like so. And then we'll also save the location since that is just a string as well. And then we'll do data.location like so. Now, as I said, we're not doing the cuisines yet, but you'll see later how I can add them in using some sets. So now that we've got our hash data, let's go ahead and write this to Redis. So what we can say is we can say const and then add result here. This is going to equal to await. Then we'll do client. And then we're going to be using hset. So this is what going to set the hash data at a specific key. And then here we're going to provide it with the restaurant key. And then after this, we can go ahead and just provide it with the hash data object that we just created. So there you go. What you'll see here is add result is going to be of type number. This is because essentially what this is going to return is any new fields it is created. So the number of new fields it's created. So you could go ahead and just see this with a console log here. What I'll do is I'll do a console log with a template here. And then I'll say, let's say added, and then we'll do the number. So that is going to be the number here of add result. And then I'll say added something field like so. After this, we can go ahead and just return a success response as everything has been handled successfully. So we'll use that success response helper that we created earlier. Inside of this, we'll pass it through our result. Then we'll pass it through the data that we have, and that's just going to be hash data here. You don't actually need to return anything, but obviously it's quite nice to return the newly created ID in case you want to reroute on the front end. And then after that, what I'll do is I'll add in a nice message, and I'll just put something like added new restaurant like so. So now that we've done that, we can go ahead and get rid of this result.send hello world down here. We can go ahead and save this, and we can test our new endpoint now. So back in Insomnia, you may remember we were sending a post request with this information before, and we were just getting that hello world response as we hadn't had any of the logic. But now let's go ahead and hit send. What we should see is it's success of true. We've got that message that we've added a new restaurant. We've got the new ID for that. And then I'll also just return some of the other data as well. Obviously, you could just return the ID if you wanted to, as you probably know this information as it's literally what you just sent over. But now let's go ahead and load up Redis Insights to see what this data actually looks like in Redis. So if you recall from when we set up Redis, we actually included Redis Insights by using the Redis stack, and that was binded to the port 8001. So we go to localhost 8001 here. You should get a UI that looks something like this. You may have to agree to some terms. What you can see is essentially a visualization of our Redis data here. And what you can see is we essentially have the groupings in a nice tree structure here. You can also do a list view. Obviously, this tree structure helps us take advantage of these keys and the groupings that we've been doing. And then here you can see we have that bytes, so the prefix for my application. We have that restaurants folder here. And then we have that newly created hash that we have. And then inside of here, the hash has the field of ID, name, location, and the values. Now with Redis Insights, you can actually go ahead and change some of these as well if you wanted to from this nice UI here. Let's go ahead and create another restaurant now. Now, one thing I do want to point out at the moment is if I sent the exact same information through, you would see that it would add it with a new ID. We're going to be looking later at how we can make sure that we're not adding multiple restaurants that are the same thing. So we'll be doing a check based on the name and location, making sure we can't have more than one restaurant with the same name and location. We'll be handling that in the Bloom filters section. But for now, let's go ahead and just rename this restaurant. Let's say I called this one Better Cafe here. And we'll also go ahead and send this through with different cuisines. So let's say if I send this through as Mexican and then hit send here, let's go back to Redis Insights. Let's hit back here and then we can hit refresh up here. And you see we've got those new hashes. And as I said, we're going to have one with a duplicate value in here as we haven't yet implemented the check to make sure that it hasn't already been added. But now that we've seen how we can go ahead and set our hash data, let's go ahead and take a look at how we can read from it. Now, back in the code, I do quickly just want to point out one thing, and that is, as I said at the start of the tutorial, we're going to be using Redis as sort of a primary data store in this instance, but this would be the point where we actually set it to the hash, where you'd also save it to your database as well. Let's go ahead and set up our get endpoint now. So let's go ahead and create a get request for a specific restaurant. So for this in Express, we can use the colon notation here, and then we can say restaurant ID. This just allows us to get the restaurant ID out of the URL. Then after this, what we'll do is we'll do async. And then in here, what we're going to do is request, but we're going to strictly type this. So what I'll do is I'll type this with request. We want to make sure we're using request from Express. So I'm going to go up here and then we'll say type inside of these curly brackets and then request like so. That just makes sure we're not using the Node one and we're actually using the TypeScript one. So down here now, this request here, we're going to make sure that we have a restaurant ID with string in our TypeScript. So for that, we're going to pass through a generic. In here, we'll say restaurant ID like so, and this is going to be equal to a string. So there we go, that is our request parameter. Next, we just need to set up the other ones. That's going to be the response and then next here. And all of this is going to be equal to a function there, or with the arrow notation. Now inside of here, we can go ahead and now get the restaurant ID out of the URL. To do that, all we need to do is say restaurant ID, and this is going to equal to request.params. And what you'll see is this restaurant ID now has the type of string there. Now what we can do is set up our try-catch block. So for that, we'll just do that try-catch that we've done before. As I mentioned earlier, if you're using Express 5, you might not actually have to do this anymore. But inside of this try-catch block, we'll just simply do a catch with an error. And then we're going to send that error to the next function. So that's just going to be next. And then we'll call that with error there. Inside of here as well, we need to initialize our client again. So we're going to do const client, and this is going to equal to await initialize Redis client. Now, if you remember from earlier, this isn't strictly true that we're initializing the Redis client each time. This is just going to go ahead and return a client if there has been one set up already. The next thing we need to do is go ahead and get the restaurant key, because as I keep mentioning, everything in Redis comes back to a key. So we'll do restaurant key, and we'll use what we had earlier. So it's going to be restaurant key by ID, and we'll pass through the restaurant ID we got from the URL. Finally, we can go ahead and get the restaurant data itself. For that, we can simply say const restaurant here equals await, and then we'll do client. And then we're going to do what is called hgetAll. You can do hget. This is how you'd get an individual field on our hash. But if we want to get all of the values and all of the fields from our hash, we do hgetAll here. And all we need to pass this is the key now. So that's going to be the restaurant key. And we can go ahead now and return this successful response here. So that'll be success response. And then we'll return the result. And then we'll also return that restaurant data here like so. And go ahead and save this. And we'll go ahead and test our new endpoint. So back in Insomnia now, I'm actually just going to note down this ID of a restaurant that we created earlier. I'm going to go ahead and create a new request. Obviously, that's going to be a GET request. That's going to be at localhost 3000 here. And then as I mentioned, this is simply just a GET request to /restaurants. As you remember, we did our route handlers. And then this is going to be the restaurant ID here. So this is what my URL looks like. If I hit send now, we should hopefully see we get back that information for it. As you can see there, we got back that message of success being true. And then we also got the data for our restaurant. Now, one thing you may have noticed is I didn't do any check that the key actually exists. Let's go ahead and pass through a random ID like so that we know doesn't exist in our Redis data. If we go ahead and hit send there, you'll see that actually still comes back as a success, but the data object is just empty. Now, we can actually add in a check in Redis to make sure that the key does exist first. So back in our code, we could actually handle this in this router.get here, but since I have a load of URLs and endpoints that need a restaurant ID, I'm going to go ahead and create a middleware for this, as again, it's just going to reduce the amount of code duplication. So in middlewares here, what I can go ahead and do is I can just say check restaurant ID. So restaurant ID like so. Let's make sure we spell restaurant correctly there. And this is going to be .ts. Now inside of this file, what I'm going to go ahead and do is import the types that we've used before for our Express middleware. That's going to have a request like so. This is going to have a response, next function, and this is all going to be from Express like so. Next, what we're going to do is we're also going to import the initialize Redis client, as our middleware here needs to be able to access Redis just to check that that key exists. After this, we can go ahead and import the helper that we created just to get that restaurant key by ID. So it's going to be restaurant key by ID. And then we're also going to import the error response, as we'll be using that in a bit to make sure that we send back an error if the restaurant doesn't exist. And there we go, we can go ahead and create our middleware. That is going to be export const, and then what I'll do is check, and then restaurant exists like so. Again, this is going to be equal to an async function. So this here is going to be async. We're going to have our request. That's going to be of type request from Express there. We're going to have our response. That's going to be of the type response. And then finally, that's going to have the next, which is going to be next function like so. So again, similar to how we set up the other middlewares. And then inside of this function, this is where we're going to run the logic for trying to get the restaurant ID and checking that that key does exist. So the first thing to do is obviously get out the restaurant ID that we're looking for. For that, we can do the same thing we did in the other function where we did restaurant ID equals request.params. Now we may want to add a check here just to make sure that we are actually getting through a restaurant ID and that you're not running this middleware where you haven't got a restaurant ID. To do that, we can simply say, after this line here, we can say if, and then we can say not the restaurant ID. So if restaurant ID is falsy, because at the moment you can see the value is string or undefined. And then inside of here, I will return an error response. So using our helper there, I'll return the response. We'll do a 400. So as I said, that's going to be a bad request. And then what I'll do is I'll simply say the restaurant ID was not found, like so. Now down here, we need to initialize our Redis client. So that's going to be const and then client. This is going to equal to await and then initialize Redis client like we've done before. Next, what I need is I obviously need the restaurant key now. So what we've done before with the keys, that's equal to restaurant key by ID, passing through our restaurant ID. And then finally, we can go ahead and check if this key exists in Redis. Luckily, Redis has a really useful helper function. That's going to be const exists here. And that is simply going to equal to await and then client.exists like so. And then we'll pass through the key that we want to check whether it exists or not. And there we go. We can now say if, and then exists is going to be a number. It's going to be 0 if it doesn't exist, and then 1 if it does. So what we can do here is we can simply just say if it doesn't exist, since 0 is a falsy value. And then if it doesn't exist, we'll return another new error response down here. This one here, I'm going to say is a 404, as we'll say it's not found. And then I'll also print out a message to the user as well of our API, and we'll say restaurant not found, like so. We can go ahead now, and underneath all of this, we just need to tell Express that it can now move on to the next function. And again, to do that, all we have to do is call next, like so. We can go ahead and save this here. Again, if this looks a little bit confusing, all we're doing is we're connecting to the client, we're checking if the key exists, and if it does exist, we're going to go ahead and run the next function in our middleware chain. Otherwise, we're going to go ahead and return an error response. So let's go back and use our middleware now. What we can say with our router.getRestaurantID here is after here, we can come in here and we can say check and then restaurant exists like so. And then we'll go ahead and add a comma there. So that's going to be setting up our middleware chain. And now if I go back to 𝗖𝗵𝗽𝗀 and we send a get request for something that doesn't exist, hopefully we now see a 404 not found. It's going to say success is false and then error restaurant not found. So now we've successfully used hset to set some hash data, and we've also retrieved the hash data as well. I'm going to use one last hash function here just to show you the power of it. And for that, we're going to be adding a view count to our hash. So every time someone goes and fetches the data for an individual restaurant, I'm going to count that as a view. Now we can do this really nicely with Redis and in a performant way by using chaining. So to do that, what we're going to do is we're going to modify our restaurant down here to use the array shorthand. And the first value here, I'm going to use as the view count. And then the second value is going to be the restaurant. The reason for this is we're going to change this await client ℎgetAll to await. And then it's going to be promise.all like so. And then inside of this promise.all, we need to pass it an array of the promises. One of those is just going to be that client.ℎgetAll that we set up earlier. But then the first one is going to be the ℎIncrementBy function. So we can come in here. Let me just add in a comma before we type this. We can say client and then .h and then increment_by. So that's going to be ℎIncBy like so. Then we can go ahead and pass in the restaurant key. We then need to pass in the field that we want to increment. So for me, that is going to be one called view count. Now, as I said earlier, the hashes don't have any validation. So we need to add in a field called view count. This is simply going to do it. Even if it doesn't exist, it's just going to set up a view count field. And that's going to have the number that we're incrementing by as its first value. So now that we've done that, we can go ahead and do Command S just to make sure that's formatted. What you'll see here is view count here is now a number. And then restaurant here has the type of the data that we're expecting before. Now this promise.all notation is really powerful with Node Redis. It essentially just allows us to execute multiple asynchronous operations concurrently. And this just improves our overall performance by making these requests run in parallel. So this is a really good way to run your Redis functions if they don't rely on each other's data. And to explain that increment_by function again, essentially what I've done here is hash increment_by, and this is a nice Redis function. And then we've passed it the Redis key, or where we want the hash. And then we've passed it the field that we want to increment. So that's going to be view count. As I said, if view count doesn't exist, it's going to go ahead and create that with your increment here. And what we did here with the client.ℎIncrement_by is we've essentially said for the hash at restaurant key, go ahead and either add a field or increment the field view count by 1 here. So now let's go ahead and see how this looks in action. So back in 𝗖𝗵𝗽𝗀, if I go ahead and actually get a correct ID for a valid restaurant, so let's copy in the one that we created before. If I go back to my GET request and replace this ID with a valid one, if we hit send now, we should see that we have a view count of 1. And then every time I hit send here, you see that view count is going up by 1 as it's running that increment by function. So back in the code, I do quickly just want to point out that this view count promise that we're getting back from the result of this increment by, this is simply going to be the new number after we've incremented it. But there you go, that is the basics of using hashes in Node Redis. So let's go ahead and commit this as our step 5, and that's just simply going to be called hashes, like so. Now onto our next Redis data type, and that is going to be lists. Now lists in Redis are linked lists, and they're string values. They're really well optimized for adding and removing things to the head or the tail of the list. So if we want to add something to the top of the list or the bottom of the list, Redis can do that really quickly. Now lists are perfect for this type of use case. For example, when we're posting reviews for each restaurant, we're just going to store the review ID in a list like this for the restaurant. This means if you wanted to go ahead and get the most recent review, or let's say the 2 most recent reviews, we could go ahead and just read the bottom 2 values from this list. And as I said, with Redis, that's going to be handled really quickly. So like before with hashes, we have some of the basic commands that you could run here. So you can add in the 𝐿push if you want to add something to the start of the list, or 𝑟push, again, if you want to remove something like that. And then you can also go ahead and extract a range of elements from the list. So let's go ahead and implement a few of these. So over to the code then. As I said, what we're going to be implementing is we're going to be adding a post request, and essentially that's going to be to create a new review. And then we'll also do a get request to get all of the reviews for a restaurant. And then we'll also add in a delete as well to make sure we can delete a review. As I said, everything is going to start with a key in Redis. So what we need to do is come in here and add in 2 new key helper functions. The first one here is going to be called review key by ID. So this is how we're going to get our review list. So that's going to be review key by ID like so. And as I said, this is going to be equal to a function with a string ID here. And then here we'll simply just call get key name. And then this one here is going to be reviews is going to be our grouping. And then we'll pass through the ID. Remember, this ID, when we use it later, is going to be the restaurant ID, as we want a list of all of the review IDs for a restaurant. The next helper function that we're going to call is this is going to be called the export const, and then this will be review details key by ID. So it'll be review details key by ID like so. And again, this is also going to take in an ID of string. And then we'll do something like get key name here. And then we'll add in our grouping. This one here, I'm going to call review. Actually, this isn't restaurants. This is review underscore details like so. And then here I'll pass through the ID. And this is actually going to be the review ID when we use this. So now let's go ahead and create our endpoint. So let's go to restaurants.ts here. Now, one thing I do want to point out is that Express is going to match all of our endpoints sort of in the order that we define them. So when you have something like restaurant ID here, where it's just the path and then the restaurant ID, where this is being used as a parameter, you want to make sure that this is at the bottom. As if we had a path here, for example, like /search, and this was below the restaurant ID, it might actually try and take in search as a restaurant ID. So again, just make sure this one is at the bottom. But first, we want to create the endpoint for creating a review. So above here then, let's go ahead and do router.post like so. Now we're going to be getting the restaurant ID from the URL, as we want to make sure we're posting a review to a specific restaurant. Then we can go ahead and simply just do reviews like so. What we're also going to do is we're going to use that middleware we created earlier to check that that restaurant ID does exist, as we don't want to add a review for a restaurant that doesn't exist. Then we're also going to use our validate middleware that we created earlier, and we'll use that review schema we created as well. Now, finally, we can go ahead and handle everything if it has passed all of those middlewares there. So what we'll do here is we'll do an async, and then inside of here, we'll do a request. We're going to go ahead and type this again as we want the restaurant ID. So it's going to be request with our angled brackets here. That's going to have restaurant ID like so, be a string. And then finally, after this, we're just going to have the response, and then next like so. And we'll go ahead and run this function like that. So now inside of these brackets here, we can go ahead and add in our logic. So what we'll say is const, and then we'll do the restaurant ID. So we'll extract that from our params. So that's going to be request.params like so. That should have type string. Now underneath here, we can go ahead and set up our data. That's going to be const data here. Now, as I said, we've already run our validate middleware on this. So we can go ahead and safely assert our request body here as request body, and that's going to be as a review like so. So now our data should have the structure of review and a rating like that. Now what we can do is we'll do our try catch block for anything where we're initializing our Redis client. So we'll do try, then we'll do catch. This is going to be error. And then again, we're going to go ahead and pass this off to next error just to handle that error for us. And then inside of here, we'll set up our client. That's going to be const client, and that's going to equal to await initialize Redis client like we've done before. Now next, similar to when we create a new restaurant, we're also going to want a review ID. So this one here, I'm actually just going to call review ID just to make it clear which one we're working with. And then again, I'm going to use nano ID to generate that for us. Next, we also need the keys that we're going to be using in Redis. So one of them is going to be the review key. This review key here is going to be that review key by ID function we created earlier. And I'm going to pass this the restaurant ID. Make sure it's the restaurant ID we're passing to this, as this is the list for a restaurant of all of the review IDs. Next, we're also going to want the review details key by ID. So this one here is going to be called review details key. And again, we're going to be calling that function, which was the review details key by ID. And this one here is where we'll pass in our review ID like so. And then finally, we're also going to want our review data. So for that, what I'll do is I'll do const review data. Now I'm going to want mine to include the review ID, as again, I like to store that in the hash, even though it's already in the key as well. So I'll say ID here is going to equal review ID. And then I'm also just going to use the spread operator on the data. Another cool thing we could add in as well, though, is a timestamp, and we could set this timestamp to date.now, for example. And then we could also add in the restaurant ID that the review is for. Again, it's just quite useful to store this on the hash as well, even though it's in the key. So we'll also store restaurant ID like so. Now we can go ahead and actually set the review details and the review list in Redis. So to do that, what we'll do underneath here is we're going to do a promise to all like we saw before. This is just making sure that this is run sort of asynchronously and concurrently and does it all in a nice parallel operation. So we'll do await promise.all like so. And then inside of here, we're going to do an array of the functions we're going to be running. The first one here is going to be client.lpush. So this is the one where we're going to be pushing the review ID to a list. So we'll do lpush. This is where we want the actual review key. And then we're going to pass it the review ID like so. So what we've done here is we've essentially said we have a review now with this review ID. But now what we need to go ahead and do is actually store the data for that review on a hash. Now this will be a little bit more clear when we go in Redis Insights and see the structure of this. But for now, let's go ahead and do client.hset like we saw in the previous one. So we'll do .hset. And then we're going to be doing the review details key. And then finally, we can pass it our review data like so. So that's going to be review data. And we'll go ahead and save that, and that will format there. And now after all of this, we can go ahead and just return a successful response. So that's going to be success response. And then inside of this success response, I'm just going to return the review data that has been created. And then I'll also just send back a message that says review added like so. So now let's go ahead and test our new endpoint. So inside of Insomnia, again, I'm just going to get the ID for one of our restaurants. So let's go ahead and copy one that we've used before. I'm going to go ahead and create a new request. This is going to be a post request now, and it's going to be to localhost 3000/restaurants, like so, and then slash the review ID, or the restaurant ID, sorry, and then slash reviews like this. If we go ahead and click send now, we should see we get back those Zod errors as we passed in that middleware. So let's go ahead and send in the data via JSON that we're expecting. So what we're expecting here is we're expecting a key, which is review. So let me go ahead and type that in. That's going to be a review. And let me just say great food or something like that in here. Then we're also expecting a rating between 1 and 5. So we'll do rating here. And I'm just going to set this one to 5 like so. Let's go ahead and hit send now. And what we see is we get a 200 OK, and it's coming back with our new review ID. And as you can see, this is the data structure that we stored in that hash there. So we've got the ID of the review. We've then got the actual review text content, the rating, the timestamp this was created at, and then finally the restaurant ID as well. So let's take a look in Redis Insights what this looks like. So in Redis Insights now, what you can see is we have two new groupings. One of them is simply this reviews grouping. This is where we've got the list that we just created. Now this list here, this is going to be the restaurant ID. And then inside of here, we would have a list of all of the review IDs for that restaurant. So what you can see here is that's just simply a string of the review ID. And the reason we would do this is we can then come into this list, look up, let's say, the most recent review by just looking at the top of the list or the bottom of the list, depending on how we added it. And then we could go ahead and get the actual details from that review from this review details hash that we created. And there you go, you can see all of that information for that review. Let's go ahead and send a few more. Let's just go ahead and spam the send button here. And let's go back to Redis Insights. Let's hit refresh here. If we now click back, what you'll see in our list is our most recent review down here is going to be at the top of our file with this lfyf thing. We can verify that by going back to Insomnia, and you see that our most recent review ID is this lfy1, and you can see that was at the top of the Redis Insights list there. So now that we've got the lists and the review details, let's go ahead and see how we can retrieve a range from the list and then map that with the review details as well to return a nice endpoint of all of the reviews for a restaurant. So let's go back to the code. And then underneath this endpoint that we just created, so this router.post one, I'm also going to head and create a new GET request. So that's going to be router.get. We're again going to get the restaurant ID as we want to get all of the reviews for a restaurant ID. So that's just going to be restaurant ID like so, and then reviews. And then here what we can do is we can go ahead and make sure that that restaurant does exist. Otherwise, it's just not going to have any reviews. And then finally, we'll go ahead and then pass in the functions like we've done before. That one here is going to be request. This is going to be of type request, and then this request here is also going to have the restaurant ID on it, like so. And that's going to be of type string. And then we're also going to have the response and next. And then let's go ahead and run this function here, or expand this function. Inside of here, we'll go ahead and get our restaurant ID out again. So it's going to be restaurant ID, and this will equal request.params like we've done before. Now with this endpoint, we're actually going to have this use pagination, as it's a great example of why lists in Redis are really powerful. So for that, what we're going to do is we're going to get the page number and the limit that we want for each request out of the search params. So to do that, what we're going to do is we're going to say const and then page. We'll have a default of 1, so we're just going to start on page 1. And then we'll also have a limit, and we'll have a default size of 10. So we want 10 items per page. And this is going to equal to the request.query. Now this is essentially, if we were doing a URL, you'd send it through with the question mark, and then you'd say like page 2 if you wanted page 2. Now what we need to do is go ahead and calculate what we'd want out of our list. Now remember, lists start at 0 index, so we're going to do a bit of maths for the start and end of the list based on the page number. So for that, what we'll do is we'll say const start here. So this is the index that we want to start fetching from, or the start of the range that we want to get. For this is going to equal, and then we'll do brackets, number, and then page, since page up here could actually be a string. And then after this, we'll do -1. And then we're going to have to times all of this by, again, we'll wrap number, and then this will be with the limit here. So what this is doing is essentially, let's say we're on page 1. Obviously, it's going to do page 1 here, and then -1, so it's going to be 0. And that means for page 1, we're starting from our list at index 0, as we would expect. Next, what we can do is we can say the end here. The end here is simply going to equal the start, and then we're just simply going to add the limit. So we'll do number, brackets, limit. And then we'll make sure to -1 as well, as lists start at a 0 index. So now that we've got that, we can go ahead and do our try catch block. So it's going to be try, and then we'll do catch here, and that's going to be error like so. And then we'll send that off to the error handler like we've done before. And inside of our try catch block, we'll also get the Redis client by doing const client equals await initialize Redis client. And then we also need the review key. So this is going to be the key for the list based on the restaurant. So this one here is going to be const review key equals review key by ID, and then we'll pass through the restaurant ID like so. So now we can go ahead and get the review IDs for that range that we've defined using the pagination. To do that, we can say const, and then we'll do review IDs like so. This is going to equal to await client, and then we're going to do L range like so. So this is going to get a range of elements off of our list based on our start and end. So for that, we just pass it our key. So that's going to be the review key that we created earlier. Then it's going to be start, and then it's going to be end like so. Now what you'll notice is the value of review IDs is a string array, as if you remember, lists can only store strings. So this is simply going to be all of the review IDs, and it's not going to have any of the review data. To get the review data, we can now map over our review IDs. So to do this, we'll say const and then reviews, so the actual review content. This is going to equal to a promise.all. Inside of this promise.all, we're not going to create our own array. We're going to use our review IDs array that we just made. And then we'll do a .map. And then we're going to turn each review ID in here as a string. We're going to turn each one of these into a promise. So this is going to be ID. And we'll do client.hGetAll. And then we'll get the information for that review simply by doing review details key by ID. And then we'll pass through ID like so. And now we hover over reviews here. We should have a type of string array like so, or an object array like that. And now we can go ahead and simply return this as a successful response. So we can now say success response. We'll do a response there, and then we'll simply pass through our review data like reviews. And we can go ahead and save that and test this endpoint now. So in Insomnia then, I'm going to go ahead and copy this URL, as we're simply going to be changing this to a GET request. I'll make a new request. I'm going to go ahead and paste this in, and then we'll go ahead and hit send. And what you should see is we now get a success of true. We get that message of success. And you'll see here the data is actually our review details, even though our list only contains our review IDs. And that's because we did that promise.all to map over all of our review IDs. As you can see, this is now a paginated list of our reviews. So we could also request page 2 if we wanted to, and if we had enough reviews. The last thing we'll do then is just make sure that we can actually delete something from the list and also the review details as well, as you may want to delete some reviews. So for this, we'll create a new endpoint. This one down here is going to be router. This is going to be .delete here. And then what we're going to go ahead and do is the path for this is going to have the restaurant ID. The reason we want the restaurant ID here is because our keys from earlier actually use a restaurant ID. So we want to know what list to delete this review from. And just having the restaurant ID in the URL is just a quick way to do this. And then we'll also say reviews like so. And then here we're also going to get the review ID like this. First, we'll check if the restaurant exists using our middleware. And then finally, we'll run our async function. Again, we're going to do request. This time, we're actually going to type this with request, and then we're going to have to include the restaurant ID and review ID on this object. So that's going to be restaurant ID as string. And then it's also going to be review ID as a string here. And then we'll go ahead and get the response, and then our next function like so. And then we'll go ahead and do something inside of this function. So let's go back now. Now inside of this function, obviously we can go ahead and get out the restaurant ID. So that's going to be restaurant ID, and then also the review ID, and that is going to equal to the request.params that we've done before. Next, we can go ahead and set up our try catch block. So inside of this try, and then we'll do catch, and then we'll pass the error to our error handler. So it's going to be next, and then brackets error like so. And then in the try catch block, we'll also create our client like we've done before. So it's going to be const client, and that's equal to await initialize Redis client like so. We also now need our keys. So one of them is going to be the review key that we've used before. This review key here is simply going to be the review key by ID. And remember, this is going to be the restaurant ID in this one. And then we also want the review details, as that review key before was simply to the list. And now this one is to the individual review details. So that's going to be review details key. And then it's going to be the review details key by ID. And this is the one that we're going to be passing through the review ID to. So now that we've got the keys, we need to go ahead and delete all of the review details. So we need to delete that hash entirely, but then we also just need to remove one element from the list. So to do this, we can simply say const, and then we'll do an array here. We're going to say remove result, and then we're also going to say delete result like this. This is going to equal to await, and then we'll do a promise.all again. So inside of this promise.all, we're now going to run client.lrem. So this is going to remove something from a list. What we need first is obviously the list ID. That's going to be review key. Then what we're going to do is we're going to say 0 here. So this is how many elements we want to remove from the list. They actually match. So if we had multiple entries for the same review ID in our list, if we left this as 0, it would delete all of them. If we put something like 1, it would only delete one of the entries. But now we'll go ahead and delete all of them, as we should only have one review ID in that list. And then we're also going to add in the element here, and that is simply going to be the review ID. So this is essentially going to check the list for this element and then go ahead and delete it if it does exist. Now we need to go ahead and just simply delete the entire hash for the review details. So for that, we can just do client.delete, and that's going to delete the key entirely. So we can do review details key like so. Now, at the moment, we're not doing any check to make sure that the review does actually exist, and that's because we don't have to. As you can see with the remove result here, it's going to be a number, and so is the delete result here, and this is actually going to be how many fields have been impacted. So what we can actually say down here is we can say if the remove result is equal to 0, so if nothing happened, and if the delete result here is also equal to 0, we can then go ahead and return an error response and just say that the review didn't actually exist, so I'll return error response here, and then we'll do something with the result here, and then we'll pass in the error message, or let's pass in a 404 first, so that it's going to be not found, and then we'll say review not found like so. Now once we've done that, we can go ahead and simply just return this successful response. So this is going to be a nice message just to say that we have successfully deleted the review. That's going to be review ID as the data here, and then I'm going to go ahead and simply say review deleted. So as I said, essentially remove result here, this is going to be the number of things that have been deleted. And as you can see here, if they're both 0, it technically means that Redis wasn't able to delete or remove anything. So that means that the review probably wasn't found. And then we can just have our success response. Let's go ahead and test this out in Insomnia then. So in Insomnia, I'm going to go ahead and copy the URL that we used for a previous request. I'll do a new HTTP request. As you can see, the URL is essentially going to be restaurants and then / the restaurant ID / reviews. But then after this, we also need the review ID we're going to delete. So for that, I'm going to go back to my get reviews endpoint, and I'll just copy one of these IDs that we've created. Then I'll go back to this and I'll put / and then this ID here. And we need to change this to a delete request. Let's change that to a delete request. Hit send, and you see we get success true. The review has been deleted, so it's now being removed from our list, and we've also removed that hash details as well. And if we sent this again, what you'd see is we'd get 404 review not found, as we just deleted it. So there you go, that is the basics of using lists in Node Redis, and you've seen how we can use lists for things like the review IDs, just so we can do simple pagination and various different operations, and make sure we're doing them really quickly. Let's go ahead and save all of this as step 6 lists. So let's take a look at Redis sets now. So sets in Redis are an unordered collection of unique strings. This makes them really powerful for tracking unique items, and you can also do a bunch of set operations as well, such as finding the intersection of two sets and various different things like that. So in our use case, what we'll be doing is tracking all of the unique cuisines that have been added to our restaurant directory. So say we added 10 restaurants with the Italian cuisine. We don't want multiple entries for these when we go ahead and get all of the cuisines that we have in our restaurant directory. We just want one entry to know that that is in there. And that's going to be the same for all of the cuisines as well. Now we're actually going to be utilizing 3 different sets. Now the reason for this is it just really helps with indexing and getting information really quickly. So as I said, our first set is simply just going to be all of the unique cuisines on our restaurant data. But the second one here is going to be for each cuisine, it's going to be the IDs of restaurants that have that cuisine. And then our third one here is simply going to be for a restaurant. So let's say for restaurant 1, what are the unique cuisines on that restaurant? So this is simply how we're going to be storing the restaurant cuisines, because if you remember from earlier when we did our hash, we actually got rid of that cuisines array. This is where we're actually going to store it now in a set, just to make sure that it is unique. And as I said, we're utilizing 3 sets here, just so we can get that information out really quickly, and we don't have to do any complex searching or anything like that. We have 3 sets essentially acting like an index. So now down here, you have some of the basic commands that we're going to be using. So you have something to add to a set. Now that's going to add a new member to a set, or it might simply just ignore it if it's already in that set. You have remove. Then we can check if something is a member of a set really quickly. And then you can also get the set of members that 2 or more sets have in common. So that's, as I mentioned earlier, we can do set operations like finding the internet section. And then you also have here scard here, which is return the size or the cardinality of a set. Let's go ahead and look how we can implement this in Node then. So back in the code, let's go ahead and set up our Redis keys for these 3 sets that we're going to be creating. Let's go to keys here. The first one is simply going to be a static key name, and that's because we're just going to have the list of cuisines. We don't need to pass an ID through to that or anything. So this is simply going to be cuisines key here, and I'm going to make this equal to get key name, just so we have our prefix, and that's going to be cuisines like so. Let's make sure this is export const here to fix that error. The next one is going to be for the set of how we get all of the individual restaurant IDs for a cuisine. So this one here is going to be equal export const and then cuisine key like so. This is going to equal get key name, or this is actually going to be a function, that's going to take in the name of the cuisine like so. And then we'll do get key name, and then this key here is going to be cuisine. And then it's going to be the cuisine name here, like so. Now, the last one is going to be for getting the cuisines of a restaurant. So this one here is going to be export const. And then what we'll call this one here is the restaurant cuisines key by ID. Now, that's quite long, but we'll go ahead and make this a function that takes in the restaurant ID. That's going to be ID of string. And then we'll call get key name like so. And then inside of here, I'll store this as restaurant underscore cuisines, and then store the ID like so. So we've built out our helper functions there. So let's go ahead and use these sets. So if we go to our restaurant.ts route, we need to go ahead and actually modify our restaurant creation to handle adding those cuisines to a set. So we scroll up to where we create a restaurant with that post request here. So it's going to be this one here. What you see is we have the add result that we've used before, and that's simply just going to be a number of how many fields have been added. We're going to modify this behavior though to have a promise.all, as we want to run a few other functions such as adding to our cuisines. So here what we'll do is we'll change this add result to be await and then promise.all like so. And then we'll just set up the array in there with that existing H set like that. Now what we need to do is we need to go ahead and add to 3 sets for each individual cuisine. As you may remember earlier, our data actually has cuisines as an array. So to do this within this promise.all, we're going to use the spread operator first. So at the top here, we'll do the spread operator. Then what we'll say is we'll say data and then dot cuisines. And then we're going to map over all of our individual cuisines and create a promise. And that promise is simply just going to be adding each cuisine to one of those sets. So the first thing we're going to do in here is we'll do the cuisine name in this map. And this is simply going to map, let's make sure we spell that correctly. so cuisine name, and that's simply going to map to another promise.all, and that's why we did the spread operator earlier. And then inside of here, we'll have an array, and this is where we'll do our set operations. Our first one is going to be client.sadd here, and then what we'll do is we'll just add to the cuisines key. So remember, this is just going to be the list of individual unique cuisines. So we'll simply just add the cuisine name to that. Next, what we need to do is we need to go ahead and add to the set of the cuisine and the restaurant ID. So for this one, it's going to be client.sadd again. This one here is going to use the cuisine key like so, and that's going to be the one that we actually build out with an ID and or with a name. So that's going to be the cuisine name here. And then finally, we're going to add the restaurant ID to this set. And then our third set is going to be client.sadd here. And this one is going to use that restaurants key, cuisines key by ID here. And this one here is going to be for the restaurant ID. So that's simply going to be ID. And then here, we're going to store the actual cuisine name again. Let's go ahead and save that, and it will format that. And then we also need to make sure we add a comma here. But that may have sounded really confusing. As I said, go back to the explainer if you need to understand what each individual set is doing. But again, the reason we do this sort of spread operator here and then we map over our cuisines, because cuisines could be an array. Say we could have something like Italian and French here. We want to make sure that we're doing an operation on each of those cuisines. And then I use the spread operator up here just to make sure that we handle all of the promises in this first promise.all. Now, add result here is going to be a bunch of numbers for all of the different return results that we have here. I'm just going to go ahead and get rid of this console.log now, as I don't actually need that. We could also simply just get rid of the add result here as well, and then just save that as a promise.all, and that will go ahead and add all of those cuisines for us. So let's go ahead and test this endpoint now. So back in Insomnia, I'm going to use a post request that we've used before. And as you see, I'm adding those two cuisines there of Mexican and French. If I go ahead and hit send here, let's hit send, let's say 3 times. So if it wasn't a set, we would see Mexican in that list 3 times. But since it's a set, we're hoping we only see it once. And I'm also going to go ahead and let's just change this value here to Italian, for example. And I'll send that through once. Now let's see how this looks in Redis Insights now. So over in Redis Insights, if we expand our bytes grouping here, what you can see is we've got a few new entries. One of them is just this set of all of the cuisines, and we should see we have Mexican, French, and Italian. And as I said, that's now a unique members. And if we go back here, you see that we have cuisine here. And then for each cuisine, we can click into this set, and then we have the list of restaurant IDs that have that cuisine. And then finally, we also have restaurant underscore cuisines. And this one here is simply going to be for each restaurant ID. What cuisines does that restaurant have? So hopefully seeing this data laid out in Redis Insights there has helped you sort of understand why we need those 3 individual sets. Let's go back to our code now though. And when we have a GET request for an individual restaurant, let's make sure we're also returning the cuisines for that restaurant. So we need to go and find the GET request that we created for an individual restaurant. So that's going to be at the bottom here, since it's just this restaurant ID one. Now where we have our restaurant information, we also want to go ahead and get out the set information. So what I'll do here is I'll do cuisines. And then down here, what we can say is we'll do client. And then we're going to go ahead and do S members. So this is just going to get everything in the set. And then we also need to go ahead and get the restaurant cuisines key by ID. And then we're going to pass through the restaurant ID here. So restaurant ID, and that should go ahead and get all of the cuisines for us. And that should be on this here. So that's a string array. And we can go ahead and return that in our data. So I'm going to change what we were returning our data as then we're going to use the spread operator on restaurant. And then finally, I'll pass it our cuisines here. And if I go ahead and test this in Insomnia now, we should see that the information we're getting back now includes the cuisines for a restaurant. So over in Insomnia then, if I go ahead and copy one of the IDs for a restaurant we just created, I can then go to our get restaurant by ID, change this ID up here to that one we created, hit send, and you see we're now getting an array of the cuisines back. Even though the hash information for the actual restaurant itself can't have an array, we can now use the sets that we created earlier, and that's why we created those 3 sets to help with that indexing, to get the array of cuisines really quickly. So we've seen how we can go ahead and get all of the members for this set here, but let's go ahead and set up our other endpoints. Now this is actually going to be handled in our cuisines route that we set up earlier. So inside of here, what I'm simply going to do is do a router.get here. And then what I'll do up here is we'll simply say slash. So if we just go to /cuisines with a get request, we're then going to get some information out here. That's going to be the request. We'll get the response, and then we'll also get the next function as well to handle our errors. Inside of here, we'll simply do our try catch block for the Redis client. So it's going to be try catch. It's going to be error, and then we'll pass that through to our error handler by doing next error like so. In here, we'll set up the client like we've done before. Const client equals await, and then initialize Redis client, making sure we're importing that. And then finally, we can go ahead and do const and then cuisines here. This is going to equal to await client and then .s members again. And then here we're going to need the cuisines key like so. So that's going to be cuisines key. So this is just going to be the static one, as it's just going to be the list of our unique cuisines. And then finally, I can go ahead and return this as a successful response. So I can go ahead and say res, and then we'll return all of the cuisines like so. Let's go ahead and see what this looks like in Insomnia then. So over in Insomnia, let's go ahead and create a new request. This is going to be a GET request. This is going to be for localhost 3000, and then it's simply going to be for that /cuisines endpoint. Let's hit send, and you can see we're getting back a list of the unique cuisines for all of the restaurants in our directory. The final one we're going to set up then is going to be to get all of the restaurant names for a specific cuisine. So let's find all of the restaurants that have an Italian cuisine. To do that, we're going to go ahead and add a new route. So we can say router.get, as this is going to be a GET request. Inside of here, we'll say / and then :cuisine. So we'll get the cuisine out of the actual parameters. Then here we'll do async, and again, we'll do the request, we'll do the response, and next. And then inside of here, we'll do that try catch block that we've done before. But first, let's go ahead and get the cuisine name out of the parameters. We'll say request.params like so. Then we'll do our try catch block. So it's going to be try like this. Catch, and then we'll pass the error through to our error handler by doing next brackets error. And then we also need to go ahead and set up the client. So it's going to be const client here equals await initialize Redis client. Then we can say const and then the restaurant IDs. So if you remember, we were actually only storing the restaurant IDs in the actual individual cuisine set. So we're going to map over these later, but we'll do const restaurant IDs equals await and then client. .s member like so. Then we need to build out the restaurant or the cuisine key. So that's going to be cuisine key like so. This is going to be need to pass the actual cuisine name. And that's going to get all of the restaurant IDs that have that specific cuisine using that set we created earlier. But as I said, this is simply going to be the restaurant IDs, but we want to return the restaurant names. So to do that, we can say const, and then we'll do restaurants like so. And this is going to equal to await, and we'll use that promise.all notation we've done before. And then inside of here, instead of creating our own array, as I said, we'll map over the restaurant IDs array that we got out. We'll do a .map here, and then we'll make each one of these map to a promise, and that's simply going to be client. And then we'll do hget here. We're not going to do get all, as I'm simply just going to return the name of the restaurants. You could do hget all if you want, but I want to show you using hget. So what I'll do here is I'll do hget. Then we need the actual restaurant key. So we'll do restaurant key by ID, pass it the restaurant ID that we're getting out of our map function here. And then we'll finally say the path that we want to get out. And that's simply going to be the restaurant name. Going to go ahead and save this so it formats. And finally, we can simply return the successful response like so. And then here we'll return the restaurants data that we got out. And we can go ahead, save that, and test this in Insomnia. So in Insomnia then, I'm going to go ahead and copy and paste this URL to a new request. Let's do a new request, and let's find all of the Italian restaurants. So I'll do /Italian, and I'll hit send here. As you can see, we're getting back just one. So we only have one restaurant in our data set that has the Italian cuisine, and that is called Better Cafe there. And you can see how we're just getting an array of the actual names there because of the way I mapped over that. As I said, you could change this to get back all of the restaurant information or just the information that you want. So there you go, that is how we can work with sets in Node Redis, and you've also seen how we can use sets to create a really effective index for these unique items of cuisines there. So I'm going to go ahead and save all of this as step 7, and that is going to be sets. So let's take a look at our last basic Redis data type before we move on to things like RedisJSON, Redis Search and Bloom filters. So that's going to be sorted sets. So sorted sets are unique strings, similar to sets, but they're going to be ordered by a score, and this score here is going to be a float value. This makes them perfect for something like a leaderboard, as it's automatically ordered for us. So all we have to do is update this score with sort of the live score. In our case, that's going to be the restaurant's average rating. And you know when you go ahead and get this sorted set, it's already been ordered for you. So in our application, essentially what we'll be doing is getting all of the restaurants in a paginated way, and we can do that really easily and sorted by simply just consulting this set first. So we'll get this sorted set, and then we'll just map over the restaurant IDs. Then we can go ahead and get the restaurant information that we want, for example, the name. So we also have those basic commands down here. So this is how you add something to a sorted set. Then you can get a range of members of that sorted set. You can get the rank of a provided member, and then you can also get the reverse rank as well. As it's worth noting, Z range here goes from low to high, but there's also a command as well, which is Z rev range, and that one goes from high to low when we request this. But let's take a look at how you'd implement this in our application then. So in the code, then we need to add the key for our new sorted set. So we go to keys here. This is going to be a static value. So what we'll call this is export const, and let's call this restaurants by rating key. This is going to equal to get key name for me, and I'll simply save this under, let's say something like restaurants, and then underscore by underscore rating like this. So that's going to be the key name there. Now, the first thing I want to do is make sure that we're adding a restaurant ID to my set when we create a restaurant, and that's just going to be added with a score of 0. This just makes sure if I go ahead and get a list of restaurants from my set or my sorted set, that we have any restaurant that we have created and not just the ones that have been reviewed. So to do that, let's go ahead and find the post request for where we are creating a new restaurant. So that's what this one up here. And all we need to do in this post request here is in our array of promise.all, we're going to come down here and we're going to say, let's do client. Then we're going to do .z add like so. And then we're simply going to have our restaurant key. So that's going to be the one that we just created. So that's going to be the restaurant, and then restaurants by rating key here. And then finally, we're going to add in the value and the score. To do this, we're going to do a member object here. This is going to take in a score. By default, we'll set that to 0, as when we're creating a restaurant, it doesn't have any score. And then we also need the value here, and the value is going to be a string. And for us, that's going to be the restaurant ID. So I can go ahead and save that. Next, I want to go ahead and add in the logic for updating the score when we get a new review. So for that, I'm going to have to go and find my post request for creating a new review. Now down here in this promise.all, we can actually change this to do a couple of cool things. We're going to want to get the results back from this. So let me just create an empty array now and set that to equals to. The first one is going to be the result of this _push, so this list push. So this was pushing the review ID to the list of all of the reviews that we have. Well, using this _push here, the number that actually comes back as the result is simply the length of the list. So we can actually just use this to get the length of how many reviews we have. So I'm going to call this one here review count. The second one is simply going to be for the hash set. So I'm just going to call this set result, but we're not actually going to use this one. And then what I also want to do is on the hash of the restaurant, I'm now going to go ahead and store the total rating that we have for that restaurant, which is simply going to be the total number of all of the ratings added up. So to do that, what I'm going to go ahead and do is I'll do client. Then we're going to do 𝗵𝗵𝗽𝗀, but we're going to use a float here, as a rating could have something like 4.5 or something like that. Then we're going to go ahead and use the restaurant key here. So we need to actually create that. So that's going to be restaurant key by ID here. And then I'll simply pass through the restaurant ID in here. And then finally, we'll add in what we're going to increment our field by. So the first field here is simply going to be total stars. This is what we're going to be incrementing. And then we're also going to have our star number here, which is simply going to be the data.rating. So that's what we're going to increment our total stars by. Now, the reason we did this is this increment by float now, when we run this operation, this is going to simply return the total amount of stars. So in this array up here, we can now say total stars. So you can see how we can now use the total stars and review count here to calculate a new average score. Now, since I'm going to be reusing the restaurant key here, I'm actually going to go ahead and take this out, and then let's say we define this up here. So I'll say const, and then restaurant key. This is going to equal to the value that we just copied. Let's make sure we actually spell that correctly, like so. And then I go ahead and replace it down here with that restaurant key that we just created. So now that I have my total stars and the review count, let's go ahead and calculate our average. Now, what I'll do for this is I'll say const, and then I'll say average rating like so. This is going to equal to, I'm going to map this to a number, since I'm going to be using the JavaScript to function toFixed to turn a number into a string with a set amount of decimal places, but then I also need to transfer this back to a number. So to do that, what I'll do is I'll say number, then inside of here we'll do brackets. We're going to do the total stars. That's going to be divided by the amount of reviews we have. And then finally, as I said, I'm going to run the toFixed function on here just to make sure that we're only doing to one decimal place for the actual average rating, as that's all I'm going to want. So now we have an average rating. Let's go ahead and update the score in the sorted set. But what I'm also going to do is I'm also going to add a hash field onto our restaurants just for that average stars. So we can go ahead and find that in a nice place on the hash. So for that, we can simply do await promise.all, since we're doing multiple operations here. Inside of here, we'll do client. We're first going to add to the sorted set, or at least update the score in the sorted set if it's already in there. And what we'll do inside of this Z add is we're going to need the key that we're going to be using. So that one was the restaurants by rating key like this. And then inside of here, we need the member we're going to be updating. First, we'll do the score. That's going to equal to the average rating. And then finally, we'll do the value here. And that's going to be the restaurant ID that we're creating the review for. Now, as I said, I also want to store that average review just on the hash of the restaurant information. So for that, I can simply say client, .hset like so. And then in here, I'll use that restaurant key that we used earlier. And then I'll also update the average stars field like so. And then finally, I'll provide it with the new average stars value that we have created, or the average rating like so. Now, before we go ahead and actually create the get endpoint to get all of our restaurants sorted by that average rating, let's take a look at how this is going to look in Redis Insights. And to do that, we need to go ahead and send a few reviews in to make sure that we have a new ranking. Quickly though, since we've been building out this data structure, some of these aren't going to have a rating by default. What I'm actually going to go ahead and do is just delete everything in our Redis cache. Now obviously be very careful if you're running this in a production environment or on data that you care about. If I do flush all here in the workbench, that's going to delete everything that we had in this Redis cache. The reason I'm doing that is just so I can start from new with all of that new rating logic that we've added. So if I go ahead and load up Insomnia now, let's go ahead and create some restaurants. So the first one here is going to be Better Cafe, like so. And then as well, let's say if we have one called Better Foods, like this. And I'll also add a third one here, and then we'll just call this Better Fast Food. And then finally, I'll add in a fourth one, just so we can see a nice ranking here. And what I'll call this one is Better, and then we'll do Breakfast, like so. So now that we've got 4 restaurants that should be added to our Redis database, let's go ahead and create some reviews for some of these. So for this one, I'm going to copy this ID that we just got here, and then in create review here, I'm going to replace this one with our restaurant ID. And what I'll say for this one is great food, and I'll send that in as a rating of 5. I'm going to hit that a couple of times. Then I'm going to change my rating to, let's say, if I did a rating of 4, send that through a couple of times, and then a rating of 1 there. So we have a load of reviews for this restaurant now, and then we also have the rating, so we should see it scored by the average rating. Let's go ahead and get another ID for another restaurant. So I'm actually going to call this Better Breakfast 2, for example, send this in. Now if I go ahead and copy this new restaurant ID, we can create some reviews for this one now. So let's go ahead and replace this ID here with the new ID we just copied over. And then I'm going to send a load of ratings of 1 here. And then maybe let's send through a 3 rating, as this restaurant wasn't actually that good. Now, when we go ahead and see our set, we should see that it's automatically been sorted by the average rating. So back in Redis Insights then, if we hit refresh here, we should see all of the individual keys that have been built out as we have added in the restaurant data. And you can see here we have a new sorted set, and that is restaurants by rating here. If we click into here, you can see that we've got the restaurant IDs. And as I said earlier, we're going to add in 0 if we don't have any reviews for that. But then you can see we've also got it sorted by, as we said, this is going low to high, but it's automatically sorted itself with the restaurant ID here being the one with the highest rating. And then the second rating is obviously the one below it there. So you can see how we can then use this to add in a paginated list of our restaurants by that rating. Now, another thing as well, if we go to our restaurants and then actually see the individual hash data, you'll notice that we also, or for one that has actually been reviewed, you'll notice that we also stored the total number of stars there, and then also the average stars for that, just on the hash information there. So you can go ahead and request that if you wanted to, and that's another place that you could find the average stars. So let's take a look now at how we would get the paginated list of our restaurants sorted by that rating. Back in the code, then we need to create a new endpoint. For this, I'm actually going to go to the top of the file here. This one is simply going to be router.get, and we're just going to use what we get at the top level, so at /restaurants here. The next thing we're going to do is we're obviously going to define that async. That's going to be the request, the response, and then also the next function that we've used before. Inside of here, we can go ahead and get the page number and the limit out like we did before when we did some pagination. So for that, we'll get that out of the query parameters. So we'll do const here, and then we'll say page. It's going to be a default page of 1, and then a default page size here of 10. And this is simply going to equal to the request.query. Next, we need to also do the maths for sort of getting what the range that we want out of that sorted set by using this page and limit here. So for that, we can simply say const start here. That's going to equal the number of page, because remember, page up here might actually be a string. We're going to wrap this all in brackets here, as we need to minus 1 from this page number to get 0 because our list is a 0 index. And now that we've got that, we can go ahead and times this by the number of the limit as well. So as I said, let's say we were trying to get the information for page 1 here. This is going to go ahead and equal 0. So our start index is going to be 0. And then again, if we were trying to get the information for page 2, we would want the elements starting at the index of 10. So simply this is going to equal 1 here, and then we're going to times it by 10. So that's equal to 10. So this is how we can add in that pagination sort of index logic there. And then finally for end, this one is a little bit simpler. We just take the start number and then we add the limit number to it like so. So now let's go ahead and request this data from Redis. So we need to do our try catch here. Then we'll do the catch, and then that's going to have the error handlers that we've used before. So inside of here, we'll do next and then error like so. Then we need to set up our Redis client. That's going to be const client equals await. Initialize Redis client. So now we need to go ahead and get our restaurant IDs for the first page. And as I said, this is going to be using our sorted set. So we know it's going to be automatically ordered for us. So for this, we can simply say const and then restaurant IDs like so. This is going to equal to await. Then we're going to do client. Then we're going to use the Z range function like this. Then we need to pass it the key for that sorted set. So that was the restaurants by rating key. Then we need to pass it the start for the range and then the end for the range. So that's what we calculated earlier. And then we can go ahead and hit save on that. So that formats. The next thing we're going to want to do is, as I said, since this is just the restaurant IDs, to make our endpoint useful, we're going to do what we've done before and simply map over the restaurant IDs and then get the actual restaurant data back. So for that, I can say const and then restaurants here. This is going to equal to await promise.all. Inside of here, we'll use the restaurant IDs array. We'll do a map over these, and then we'll use the ID to simply do client.h and then get all. So we're going to get all of the information back for our restaurants here in this endpoint. And then we'll say the restaurant key by ID. We'll pass it the new ID there. And there we go. We can go ahead and return our restaurants data as a successful response here. So we do success response. And then what we'll do here is we'll do the result. And then the data is going to be restaurants like so. Now there is one thing to point out, and that is that I did client.zrange, and at the moment this is sorted low to high. We can actually change this functionality by simply coming in here and adding in some range options, and then you want to set the key of rev here, and we can set that to true. So that's going to reverse that ordering for us, so this actually starts from high to low. But obviously you could utilize this as well by getting some data through from your endpoint for whether you want to start by the low list or if you want to start from the highest rated. So let's go ahead and test this endpoint in Insomnia then. So opening up Insomnia, if I create a new request, this one is going to be a really simple GET request. This is going to be to localhost 3000 and then just /restaurants like so. And we're hoping to get a paginated list back of all of our restaurants sorted by the highest rated first. So there we go. You can see we've got the success. We've got all of our restaurant information. So all of the hash information that we had for a restaurant. And you can see we've got average stars of 3.8 for our first restaurant. And then the one underneath that is 1.9. And then the one underneath that is 0. So this has been sorted for us. And as I said, we're using sorted sets there just to make that really fast. And it's really handy for something like a leaderboard based approach like this. So let's go ahead and commit all of this code that we've just done, as we're now done with sorted sets. Let's call this one step 8, and then we'll do sorted sets like so. So the next thing we're going to be taking a look at is how we can actually use this cache aside pattern with a third-party API. And to do this, we're actually going to be using Redis string. So we do have another basic Redis type that we're going to be using. And we're also going to be handling how we can set an expiry time on that data as well. So remember from earlier, essentially what we're going to be doing is we're going to be getting the weather for a restaurant's location. To do this, we're going to be using the open weather API. But what we want to do is store the weather or for that location for an hour in our cache. So each time someone tries to request that weather information, if it's not the first time, hopefully we go ahead and just use our cache. This should make it a much quicker response time, and it also means that we're not using our third-party API too much, especially if it has some usage limits. And then after an hour, we can go ahead and delete that data from the Redis cache, and it will go ahead and refresh the data from the third-party API. So let's take a look at how we implement that in Node. So in the code here, we need to set up a few things first before we can start getting the weather data. One of them is we need the weather API key, and we'll put that in our .env file here. So what we're going to do is we're going to say weather _API _key here, and this is going to be equal to the weather API key you get back from open weather. To do that, we can go to this website here. I'll leave a link to this in the description down below. Then you can go to your account, hit my API keys, and then copy the API key over. Obviously, I'm going to go ahead and delete this one after this tutorial, as you should always keep these secret. Another thing to note as well is it may take up to an hour for this API key to actually start working. So don't worry if you see some errors straight away coming back from the open weather API. Maybe just wait a little bit and see if those errors are still occurring. So let's go back to our code and paste in this weather API key then. Now what we can do is we can define some new routes under our restaurant here. So what we'll do at the top is I'm going to go ahead and minimize this. We'll just do one underneath these two get and post requests here. And this one here is simply going to be a router. This is going to be a .get here. Then what we'll do is we'll say for the restaurant ID, and then we'll go ahead and do /weather. So for a restaurant ID, we'll do /weather, and hopefully this returns the weather information for that restaurant. Next, what we can do is we can say check that the restaurant exists. Obviously, we don't want to load in any weather information for a restaurant that does not exist. And then finally, we can do our async here. That's going to be with the request. Now, this one here is going to be a type of request. This is going to have our restaurant ID inside of this object here, inside of this generic. That's going to be restaurant ID like so. And that's going to be a string. And then finally, we're going to have our response and then our next function. And then we'll do our curly braces function here. We can go ahead and get the restaurant ID out now as well. So it's going to be restaurant ID equals request.params like we've done before. Let's go ahead and format that. Now what we need to do is our try catch block for all of our Redis functionality. So we'll do try here. This should also catch an error coming back from the API response as well. So what we can do here is try and then catch error. And then we'll pass this to our error handler by simply doing this. We'll set up our client. It's going to be const client equals await and then initialize Redis client like so. Next, we actually need to set up the weather key, and this can be a value that's going to have the weather and then the restaurant ID. So for this, I'm going to go to keys. I'll set up another one. This one here is going to be export const, and then let's say weather key by ID here. This is going to equal to a function that's going to take in the restaurant ID. So that'll be an ID of string. And then finally, we'll do get key name, and then we can just add in the key as we want it. So what I'm simply going to do is just weather and then ID here. And we can go ahead and save that. Let's head back to our restaurants and use this key then. So that's going to be const and then weather key, and that's going to be equal to, and then we'll use the one that we just built. So that is the weather key by ID, passing through the restaurant ID into here. Next, what I want to do is, since we need to get the weather at a certain location, we need to go ahead and get this location data off of the restaurant hash. So for this, I'm going to go ahead and build the restaurant key. So this is going to be restaurant key like so. And then again, that's going to be the restaurant key by ID function. And then we'll pass that the restaurant ID. Underneath here, we can simply say const, and then we'll say, let's do coords first here. And then we'll do an await. And then we'll do client, and this is going to be hget, so we're going to get a hash field here. And then here we'll pass through the restaurant key, so we want to get the location off of that restaurant key hash. And then finally we'll pass through the field that we want to get, and for me that was simply stored at location like so. So this should now be a string. Next, what we want to do is we want to check that these coords actually existed. As I said, that is type string or undefined at the moment, as it may not actually exist on the restaurant hash. To do that, we can simply just do something really quickly where we say if there isn't any coords, and then we'll simply return our error response function that we set up earlier. And then in here, we can simply say, let's do a 404, and then here we will add in an error, and we'll simply just say that the coordinates have not been found like so. So underneath here, we now know that we do have coordinates. Let's split this out into the longitude and latitude. To that, we can simply say const and then long lat here. And this is going to equal to our string. And then we'll go ahead and split that by the comma there. So now that we have this, we can go ahead and fetch our weather information from our API. To that, we'll say const API response here. This is going to equal to an await, and then we'll do fetch like so. And then inside of this fetch, I'm going to go ahead and paste in the URL that we're going to be fetching from. So it's going to look like this. So it's going to be api.openweathermap.org/data/2.5 and then weather. And then we want to get back our units as imperial. We pass through the latitude, the longitude, and then we also give the app ID, and this is going to be your weather API key. So if I go ahead and save this so that it formats, what we can now do is we can simply say if the API response and then .status here. And then what we'll do is if it's a 200, so it was a success, we can go ahead and get the JSON back that we got for that fetch request. That's going to equal to await, and that's going to be API response.json like so. And then we can also do a return, and that's going to be success response. Inside of here, we'll return the result and then the JSON as well. So we're just going to return the weather information as the JSON that we got back from the Open Weather API. Let's go ahead and save and format that. Now what we'll do at the end here is we'll simply return an error response if we manage to get to this line of code, it means that we didn't get a successful response from our API. So we'll pass through the response here. And what we can say is let's do a 500. This is going to be an internal server error. And I'll just say couldn't fetch weather info like so. So that is all of the code that we need to get our weather endpoint to work, but you may notice that we're always going to be calling and fetching the data from this Open Weather Map API here. So now we can utilize our Redis cache. To do that, what we're going to say is underneath this weather key up here, I'm simply just going to do a quick check for if that weather key does already exist in our Redis cache. And if it does, we'll just simply return the data here. So it won't even get to the bit where it needs to fetch the data from the API. To do that, we can simply say const and then cached weather here. This is going to equal to await client and then .get like so, and then we'll pass through the weather key. Now what you can see is the type of cached weather here is either going to be a string or a null. Since we're storing this JSON data as a string, it will either be string or null if it doesn't exist. So we can simply add a really quick check for that. So we can say if there is cached weather, so if it isn't null here, and then we can go ahead and simply just return a success response. This success response is obviously going to have the response here. And then for the data, what we'll do is we'll do JSON.parse, as we're going to pass back our stringified JSON data into a JSON object. And then here we'll pass in the cached weather as we have it here. So this is simply going to be a string. So there we go. We can go ahead and hit save on this. We're also going to go ahead and add a console.log here. This one here is going to say that the cache was hit. This is just so you can see if we have a cache hit or a cache miss. Now what we need to do is add in the logic for actually saving the JSON data though, when we do have to go ahead and request it from our API. To do that, we'll do this inside this API response.status 200. Underneath this JSON bit here, we'll simply say await client, and then for a string, all we have to do is set here. We can then use the weather key, and then finally we can do JSON.stringify, and then we'll use our JSON data like so. So if I go ahead and save this all, we can now go ahead and test this endpoint. So back in Insomnia, if I go ahead and get the ID for a restaurant that we know is in our Redis database, we can go ahead and click add here, new request, we'll call this one localhost 3000, that's going to be /restaurants like so, / the restaurant ID, and then finally /weather. If we go ahead and click send here, what we should see is we get the weather information back from that Open Weather API key for the location, which had that coordinates there with the longitude and latitude. As I said, I just used 00 for mine. What you may notice is this took 186 milliseconds, and that's because this had to go and request the data from the third-party API. If I hit send now, hopefully this will be a lot quicker, as it should be using our local Redis cache. So hit send, and as you can see, it went down to a 26 millisecond response time there. So that was a massive saving there by not using our third-party API. However, at the moment, we are storing this weather information permanently in our Redis database, and we haven't actually set it to expire. So let's go back to the code here, and in our set here, what you can see is it also takes in some set options. So what we can do outside of this set is we can then add in some options here by doing comma, and then we'll provide it with an object here. And for this, what we'll say is EX here. So this is going to be the expiry time, and this is going to be in seconds. So for seconds, what I'm going to say is I'm going to save this for an hour. So that's simply just going to be 60 times 60 like this. And I'll go ahead and hit save here. And then let's go back to Insomnia and request the weather information for a new restaurant. So let's say if we go to get restaurants here and get a new ID here. This shows just so that we're setting the string in the Redis database with an expiry time now. So let's replace this ID here with the one we just copied. Hit send. Again, you'll see it took 129 milliseconds on the first time, as there would have been a cache miss. We'll send it again. There's going to be a cache hit, so it's got 16 milliseconds. If we go back to VS Code, you'll see that we're also getting that cache hit as a console.log here. And then if we go over to Redis Insights, we should be able to see our string data in there. So in here, if we go into bytes, we stored it underneath this weather key here, and you can see we have the two restaurant IDs that we collected the weather for. If we click into this one here, what you can see was that was just the stringified JSON. Now you may notice as well, we have this sort of time to live here. So what you can see is this one has 59 minutes as a time to live, and that is because this is the one that we set an expiry on. So we click into this here, you can see it has that time to live value there. And if we click refresh, you can see that's going down. So once this time runs out, it's going to go ahead and just delete this key from the Redis cache. So the next time someone requested the weather information for this restaurant, it would go ahead and fetch the up-to-date one from the third-party API. So there we go. That is a really basic implementation of how we can use strings in Redis, as well as how we can implement that cache aside pattern for a third-party API here. Now, this could also be your database as well, but it just shows you the power of Redis as a cache. So let's go ahead and save all of this here. This will be step 9, and I'll save this as, let's say, strings, and then also the cache aside. So I'll do plus and then cache dash aside like so, and let's go ahead and commit that. Now, what we just saw with that weather API data there is we got back some JSON data and we wanted to store this in Redis. Now, previously you may have stringified that JSON data and stored it as a string in the Redis cache like we just did. But if you use something like Redis Stack, we can actually take advantage of JSON in Redis. So as you can see here, it's going to let you store, update, and retrieve your JSON values, just like we've been doing with all of the other types. And then you can see it also works really well with the search and query, so you can index and query your JSON documents too. So what we're going to be doing is in our API, we're going to be adding additional details to a restaurant, and that's going to have a little bit more of a complex data structure, and we already created the schemas for that. So all we have to do is create the post request and the get request, and we're going to be working with RedisJSON. So the first thing we need to do is define the key for where we're going to be storing our restaurant details at. So to do that, we'll go back down to keys.ts here. This one here is going to be called export const, and then what we'll say is restaurant details key, and then by ID. This is going to be a function with the ID of string, like we've done several times before now. And then we'll do get key name, and then we'll define this one here as restaurant underscore details, like so. And then we'll provide the ID as well. So now let's go ahead and set up our endpoints. So in restaurant.ts here, what I'll go ahead and do is let me just minimize a few of these. What we'll say is we're going to add a new post request first. So this one is going to be router.post, like so. Here we'll say we need the restaurant ID, and then we're also going to add in /details here. So this is where we're going to be posting our data to. Next, what we can do is we can check that the restaurant exists, and then we can also validate our data against the schemas that we set up earlier. So one of them was called the restaurant details schema. So restaurant details schema there. And if we go into this file here, you'll see the one we set up earlier just looks like this. So we're going to have an object. It's going to have a key with links. This is going to be an array of objects that have a name and a URL. And then it's also going to have an object or a key of contact. And that object is just going to have a phone and an email. And as you can see, we're actually validating the email with Zod here. So let's go back to our endpoint now. Now that we know we have validated the schema, we can go ahead and set up what's going to happen when it's all being successful. So for that, we can simply say async. Then we'll do the request here. And remember, we need to type this out now since we're using that restaurant ID. So for this, we'll do request like so as a generic. And then we'll do restaurant ID inside of here as a string. And then finally, outside of this, we'll do the response and then the next function like we've done several times before. Now inside of here, we can go ahead and get that restaurant ID out. So we'll do const and then restaurant or restaurant ID like so. This is going to equal to the request.params. And then we'll also go ahead and get the data as well. So we say const data here is going to equal to the request.body. And if you remember, since we're validating this with Zod now, we don't need to have a data type of any. We can go ahead and safely assert this to the restaurant details that we set up earlier. So there you go. You can see our data now is going to have that type of the links as an array, and then also that contact information. Let's go ahead and set up our Redis try catch now. So we'll do a try here, then we'll do a catch, and then we'll send this error off to our error handler by simply doing next brackets error like so. And then inside of this try catch block, let's go ahead and initialize our Redis client by doing const client equals await initialize Redis client. Let's go ahead and save this so that it formats for us. And now what we can do is we're going to get the restaurant details key. So this one here is going to be restaurant details key. And then we'll use that restaurant details key by ID function to create that. So it's going to be restaurant details key by ID, and we're passing this the restaurant ID here. Now we can go ahead and actually just save our JSON data straight to Redis, and we don't even need to do anything fancy for this. We can simply say await client.json.set, then we're going to give it the key for where we want to store this. So that was that restaurant details key that we've just created. So the restaurant details like so. Let's go ahead and make sure we rename this to restaurant details key, and then change this one here as well. Next, what we need though is a path for where we're setting this JSON information. Now, since we're essentially just setting this as new JSON information, our path is going to just be a simple dot here. But essentially with this, if we wanted to just update, say, let's say the links key and the links value, we could simply say the $sign here for the root of the JSON object. And then we could do .links like this. And then that way we could go ahead and update a specific part of the JSON as well using this path. But let's go ahead and just use the dot notation here to just set the whole JSON object at a root level. And then finally, we just need to pass it our JSON value. And for that, we can literally just pass in data like so. What I'll also go ahead and do is simply just return a success response to let the user know that it's gone through successfully. So for that, we'll go ahead and do a response here. We're just going to have some empty data. And then what I'll do is I'll provide a message, and I will just simply say restaurant or restaurant details added like so. We can go ahead and save that. So you can see there how easy JSON is to work with once you have Redis stack. All you have to do is this JSON.set, and then we can simply save all of our data there as a JSON object. And now if we wanted to get this information, we'd literally just have to change that to a .get. So if I go ahead and copy this entire endpoint here, we can go ahead and paste this in down here. I'm going to change this post request to a get. We can remove this validate here as we don't need to validate any schema. We still want to check that the restaurant does exist with this restaurant ID. And then down here, what I'm going to go ahead and do is do JSON.get. Let's go ahead and get rid of the path and the data here as we're not actually setting anything. What you'll see in get is you can actually still use a path. To do that though, you'd have to do it in the options method. So we do this, and then you could say path here. So let's say you just wanted to get the links of the restaurant back. You could simply set the path here to, let's say, the $sign here, and then links. But again, we're going to be getting the entire JSON object, so I'll just get rid of this option here. We do need to go ahead and actually return this data though. So we can simply say const and then details here. And that's going to equal to that await client JSON get there. And you see that's going to have a complex type. As obviously it could be anything sort of on that JSON. And let's go ahead and make sure we return this in this details bit here with that data. I'll also go ahead and get rid of the message as well. Let's go ahead and save this, and let's test our new endpoints. So in 𝗖𝗵𝗽𝗀 then, we're first going to have to post some restaurant details so we can actually get them. So for that, we'll do a HTTP request. This is going to be to localhost and then 3000/restaurants. Now we need a restaurant ID. I'm just going to use the one that we used before for the weather endpoint. So let's go ahead and copy this. Obviously, you could go and fetch this from Redis or from our get restaurants request here. So now I'll do / and then we'll do /details at the end here. So we need to change this to a post request. Now, if I go ahead and hit send, we should see we get some errors back. And as you can see, it says that the links array is required and also the contact information array is required. That's using our validate schema. Another one as well is, let's say if I just change this restaurant ID really quickly, let's just get rid of the Y at the end. You'll see that it also returns restaurant not found using that check restaurant exists middleware. Now we go ahead and send again. Obviously, it's going to show that error, but let's go ahead and add in some JSON data. So for this, I'm going to paste in this data here, which is in the structure that we're expecting. So we have a few links in our array here with the name and URL. And then we also have our contact information down here. Let's go ahead and hit send. And as you see, it says restaurant details added. Now let's go ahead and make a GET request. So for that, I'm going to copy this entire URL up here, do a new request. Let's paste this in and let's hit send. As you can see now, we're getting back that JSON data that we just saved for those restaurant details there. So let's see how this looks in Redis Insights. We go ahead and refresh our data here. You can see if we expand our bytes object here, we now have restaurant underscore details. And if we go into here, you can see we have a JSON type, and you can click in here and you can see the JSON, and you can even edit this as well from within Redis Insights. And I'm going to go ahead and commit all of this as step 10, and then we'll just say RedisJSON. So step 10, RedisJSON like so. Next up, we're going to be using Redis Search. As you can see here, Redis Search offers an enhanced Redis experience via the following search and query features. So it has a really rich query language, and I'll show you an example of that in a minute. It has indexing for our JSON and hash documents, and you can see you can even do things like geospatial queries, which would be really useful for us as we have some location strings in our hashes. Essentially, what geospatial queries allow you to do is search for locations. So we could say, let's say around the coordinates 0, 0, for a 5-kilometer radius, return all of the restaurants in that radius. On this documentation here, you will find an example of that query language. So if we go down to this query here, what you see is you can do something very similar to how we query things in SQL. And then you can see the SQL here, and this maps to the actual Redis search query here. So for example, you could say where the price is greater than 1,000, you would do something like this. And then you have things like this simple projection. And there's just a load of other powerful queries that we can do using Redis Search. So let's see how we can actually do this for our data in Node. So in the code, we need to start off with our index key. For this, we're going to go ahead and go down to keys.ts. I'm going to go ahead and do export const, and then we'll create an index key. Now you may want to actually name this something like restaurants index key, but since I'm only going to be having one index in this example application, I'm just going to leave it like this. We'll just do get key name here, and what I'll say on this is let's do idx, so it's going to be an index, and then we'll also go ahead and do restaurants like so, just to say it's the restaurants index, and we'll go ahead and save that. Now what we need to do is something that's a little bit different to the way we've done things before. For a Redis search to work, we need an index. Now you don't really create an index from an endpoint or anything like that. So what we're going to be doing is creating a separate script that we can just run one time to set up the index for us in Redis. We'll be doing this in a new folder. Let's create a new folder called seed. And then inside of here, we'll just do a new file, and we'll simply call this one create index.ts like so. Inside of here, we can go ahead and import a few things. We need to do import. We're going to import a thing called schema field types from Redis. Next, what we want to do is we're going to import the initialize Redis client from our client.js. So it's going to be the initialize Redis client. And then finally, we also want to import the index key and then also the helper for get key name from our keys.js. So it's going to be index key here. And that's going to be in get key name like so. So now let's go ahead and actually create our index. For that, we're going to create an async function. That's going to be async function, create, and then index like so. Inside of this function, we're going to go ahead and connect to our Redis client. So it's going to be const client here, and that's going to equal to await and then initialize Redis client. Next, what we're going to do is when we run and create our index, we don't want it to overlap with an index that already exists. We want to rewrite this data. So to do that, what we're going to do is we're going to wrap a trying to delete an index in a try catch. The reason we're going to be wrapping this in a try catch is it's going to try and drop the index, but if the index doesn't exist, it would technically throw an error, but we don't want it to, so we're going to catch the error and just say there wasn't an existing index to delete. So for that, we're going to do await client. This is going to be .ft, and then it's going to be drop index like so, and then we'll give it the index key of the one we're trying to delete. And as I said, what we'll do is we'll simply just catch the error here, so we can catch error, but then I'm just going to simply do a console.log, and we'll say no existing index to delete here. Now underneath this, we can go ahead and create our new index now. So that's going to be await. This is going to be client.ft.create like so. Now inside of here, we need the index key. But then what we're going to need is the Redis search schema. So this is going to look a little bit like this. So what we're going to have is an object. The first one is going to be the field that we're searching for on our hash here. So, and then inside of this, we're going to do an object. We're going to define the type of this data. So for us, that's going to be a string. So that will be schema field types and then .text. Then what we can say is we can say, what do we want this to be called in our query language? So for that, we can say as. I'm just going to leave this as called ID, as that is what it's called. And then we can also say, do we want this to be sortable as well? Now you could obviously put true here, but I'm not going to use that as I don't really need my IDs to be sortable. Next, what we can do is we can set this up for a few more of the things that we're going to be doing on our restaurant information. One of them is going to be the name. Obviously, we're going to want the type. Again, the name is going to be a schema field type of text here. And then we can go ahead and do as like so. And then we can go ahead and save that as name as well. And another field you may want to index as well is going to be our average stars here. And as you saw earlier, using query language, that's going to allow us to actually query this based on if we want restaurants above 3 stars, above 4 stars, and all of that as well. So inside of here, we'll give this a schema. Now this is just going to be a schema field type here. And this one here is going to be numeric. And then we can also give this an as name as well. And again, I'm just going to leave this as average stars like so. And we also want this to be sortable. So let's go ahead and set sortable here to true. Now it's worth noting you don't want to put all of your fields into your index, as that can go ahead and slow it down, as your index actually needs to be recalculated every time you add something to sort of your hash. So once you have your schema index here, we need to tell it where we want to actually index our data from. For this, what we need to do is just provide it with another set of options down here. What I'm going to say is on here. Now you can either provide hash or JSON to this. So if your data is in JSON format, put JSON, otherwise put hash here. And then next, what we're going to do is the prefix for all of the hashes that we want to search for. So for us, that is simply going to be the restaurants key that we've been saving all of our data to. So what we'll do for this is we'll simply say get key name like so. And then in here, we'll do restaurants. And that there is going to catch all of the restaurants that we stored as hashes. So if it's something like bytes and then restaurants and then ID1, this means that it's going to index all of them. So we can start to use some of the powerful querying language on this. Outside of all of this, then we need to go ahead and actually run our function when we run this script. So for that, what we'll do is await, and then we'll simply await the create index function. And then what I'm going to go ahead and do is do process.exit just to make sure that our script exits once that is all completed. So we can go ahead and run this now. So to do that, I'm going to create a new terminal. Inside of this new terminal, I'm simply going to use TSX to run this. So to do that, I can do pnpm dlx. If you're doing npm, that's going to be npm mpx or mpx. And then here we can go ahead and do tsx. And then we're going to go ahead and point it to our new file. So that's going to be seed/create index.ts here, and we can go ahead and hit enter. Now hopefully it should say Redis connected, and then it should say no index to delete on the first run, but hopefully there's been no errors reported, and that is our index created, so we can go ahead and start to use this now. So let's go to our restaurants.ts here. Now at the top of this, I'm going to go ahead and define a new route. This one is simply going to be router, and then it will be a get request, and it's simply going to be at the /search endpoint here. Then what I'll do is we'll do that async with the request. So that's going to be async request response and then next. And then we'll go ahead and put some data in here. What we're going to go ahead and do is get what we're searching for from the actual query parameters, which is a common pattern you may see on something like Google, for example. This is going to be request.query. So essentially what we'll do is when we're doing /search, it'll be something like this. It'll be /search. And say we wanted to search by name, it'd be something like /search and then Q here. And that's just going to equal to name like so. So that's what we're going to be searching. So say we wanted to search for all of the restaurants that start with a name better or have better in that name, for example. That is what this would look like. So next we need to go ahead and set up Redis like we've done before. We'll do our try block. We'll do our catch. We'll handle that error with our middleware. So that's going to be catch. Next, error like so. And then in here we'll create our client. That's going to be const client equals await initialize Redis client. Now what we can go ahead and do is really quickly just call our search functionality, and it's actually really easy to do. All we need to say is const results here. That's just going to equal to await the client. Then it's going to be .ft.search. We're obviously going to provide it with the index key here. So we'll do index key. And then all we need to do is provide it with the query that we want to build out. Now, a really basic query we could do is simply the @name. So it's going to be searching our restaurant names, as I said. And then using the template literal, we can give it the value that we want to search for here. And then I can go ahead and return a success response here with our results as well. So we can say success, and then we'll return the results here. Go ahead and save this, and let's take a look at how this looks in Insomnia. So inside of Insomnia, let's go ahead and create a new request. This one is simply going to be to localhost, and then it's going to be 3000 /restaurants/search. And then what I'll do is I'm going to go ahead and add in our query. Let's say I wanted to search for all of our restaurants that have a name starting with better, for example. Let's provide it with better. Let's go ahead and hit send here. What we see is we get a success. We have 5 total matches, and you can see it's returned the restaurant data for us. We haven't had to do any promises or anything like that. It's just gone ahead and got the hashes for us. And you see we've got that restaurant of better foods there. We've got better breakfast. We've got better breakfast too, better fast food, and better cafe. Let's just change our search value here to check this is working. Let's change this to cafe, and we just get that one result back there where it's searched on the name for that value of cafe. And let's go ahead and save what we've got as step 11, and that's going to be a Redis search like so. And commit that. Now, the last thing we're going to do in our application is solve a problem for our create restaurant endpoint here. At the moment, if we go to create restaurant, if we create a restaurant with better breakfast too, and this location here, if we go ahead and hit send a few times, you can see it's going to add each one of these as an individual restaurant. We can be pretty safe in knowing that if it has the same name and the same location, we don't want to add it to our directory multiple times. So for this, we're going to be using a Bloom filter. So Bloom filters in Redis are probabilistic data structures that check for the presence of an element in a set. As you can see down here in the use cases, we're essentially going to be using it in this sort of username way, so we can check if a username is taken. Essentially what we're going to be doing is building out a string using the name and location, and using a Bloom filter, you can really quickly check whether that name and location has been added to the Bloom filter before, and if so, that means we don't want to save the restaurant data as it's already in our Redis cache. So in the code then, we need to go ahead and create a key for our Bloom filter. That's going to be called export const here. And then what we'll do is we'll just call this one Bloom key. Again, if you're going to have multiple Bloom filters, you might want to call this something else. But then what we'll do is get key name here. And what I'll save this as is I'm going to call this one Bloom. And then since it's going to be for our restaurants, I'll just do something like restaurants like so, and go ahead and save that. Now, similar to how we did for Redis Search, we actually need to create this in a bit of a different way. So we create our Bloom filter once in Redis as sort of a set that we can add to, and we're going to do that with another seed script. So in our seed file here, we'll create a new one, and let's just call this one bloomfilter.ts. And inside of here, we're going to go ahead and create the function to create our Bloom filter. That's going to be an async function here, and we'll call this one create Bloom filter like so. Then inside of here, we'll go ahead and set up our Redis client, and that's going to be using the initialize Redis client from our client.js file. Then we're going to go ahead and delete the Bloom filter if it already exists, and then set it up again. To do this, we can simply do this one in a promise.all. So what I'll do is I'll do promise.all like so. And then inside of this array here, we'll do client, And then we're simply just going to delete the Bloom filter if it exists at this key. And then we'll use the Bloom key that we created earlier. Next, we can go ahead and create the actual Bloom filter. So that's going to be client.bf and then .reserve like so. In here, we can give it the Bloom key as that's what we want to create our Bloom filter. We're going to give it an error rate. For us, that's going to be 0.0001 like so. And then we're going to also give it a capacity. We're going to be using 1 and then 0.000.000. So that's going to be a million there. Now, if you're wondering what the error rate and the capacity do, essentially a Bloom filter is going to take up a fixed amount of memory, but the amount of memory that's going to take up is going to be a function of the error rate and then also the capacity as well. If you want to look more into this, go ahead and look in the Redis documentation. What we can do now is we can simply await at the bottom of this file our create Bloom filter like so, and then we can do the process.exit as well once that has been set up. We'll go ahead and save this. Now what we're going to go ahead and do is simply run this script like we did with the create index.ts. All I need to do now is just change this one here to bloomfilter.ts. Go ahead and hit enter. Now we shouldn't see any errors, but you should see that Redis was connected as it did need to initialize a new client. And now we can use our Bloom filter. So we're going to be updating the create restaurant endpoint. So if we go to restaurants.ts, let's find the post request that we have for creating a restaurant inside of here. Now what we're going to do in here is we're simply going to have a function for if the restaurant has been seen before. But the first thing we need to do is get a string based on the location and the name of the restaurant. So to do that, what we can say is underneath this restaurant key here, I'm going to say const and then let's say Bloom string. This is going to equal a template literal. So let's do equal and then a template literal. And this is simply going to be the data.name. So that's going to be the name of the restaurant. And then I'll do a colon here. And then since my location is already in a string, I can simply say data.location. So essentially this is what it's going to be storing in the Bloom filter to check for its existence. Then we can do that check by saying const and then we'll say seen before. This is going to equal await client and then .bf and then .exists like so. And then inside of here, we can simply give it the Bloom key for the Bloom filter that we're checking against, and then the Bloom string, which is the values that we're checking against. So now what you'll see is seen before here is going to be a Boolean. So it's going to be true if it is already in that Bloom filter, and it's going to be false if it isn't. So we can simply say if it has been seen before, and we can cancel out any of the logic below this, which is the adding logic. We can simply just return an error response here. I'm going to go ahead and return the 409 code, which means it's a conflict. So it's conflicting with some data we already have. And I can simply return an error as well saying restaurant already exists like so. And we go ahead and save that. Now, the last thing we need to do though is make sure that when we are adding the restaurants that we're also adding the Bloom string to the Bloom filter, as at the moment it's only checking if it's in there. We do need to make sure that we're adding it to the Bloom filter. To do that, we can simply come down to where we've been doing these promises before. Underneath all of these, we can simply say client dot and then bf and then dot add, and then we're going to add at the Bloom key, and then we're simply going to add the Bloom string to that Bloom filter like so. Go ahead and save this, and now let's go ahead and test our endpoint in Insomnia. So in Insomnia, let's say we went to send this restaurant again. As you'll see, it needs to add it to the Bloom filter first, so it can't work on the existing dataset. But now if we go ahead and click send again, hopefully it's now in our Bloom filter, and we should get a conflict. So hit send. As you can see here, we get restaurant already exists, and we get that 409 conflict code. So that's how we can stop some duplicate restaurants being added to our directory. And that's the power of Bloom filters there in Redis. Let's go ahead and commit all of this then as step 12, and that's going to be Bloom filters. So step 12, Bloom filters like so, and commit that. So there we go. Hopefully with all of that, you've learned how to use these various Redis features in Node here. And hopefully you have a good starting point for a restaurant directory backend like we've built here. And you can go ahead and take these concepts and apply that to your own backend. Now, finally, if you do want to go ahead and build this application so it compiles to JavaScript, we can simply use the command we created earlier, which was ppm run build here. You can see that's going to go ahead and run the TypeScript compiler. And you're going to go ahead and get this dist folder out here, where then you can go ahead and then simply do ppm run, and then it was start, and that's going to go ahead and run the index.js file. And you see there, we're now running our compiled JavaScript code here with application running on port 3000, and everything should work like it had been before. So let's take a look at our learning goals from the start there. So hopefully now you have a bit more of an understanding of what Redis is, how we could use this cache aside pattern with that third-party weather API, and we also used these various Redis features as well, with some of the really powerful ones at the end there being that Redis search, the Bloom filters to make sure that we're not sending duplicate values to our database, database, and a load of various other things as well, and the power of things like sorted sets for leaderboards and sets for unique items. So if you made it this far, do go ahead and subscribe for more programming content. And if you want to Dockerize your Node application, go ahead and check out this video here, or watch the one YouTube thinks you'll like. Thank you very much for watching.